Hello, good morning. It's morning in New York City, where I am here. Time for the coding train. And I'm very excited for today because I have a couple things that I'm planning and excited to do. You are here watching. My microphone is actually on. I haven't seen anyone in the chat saying they see me yet, so who knows if this is actually live streaming, but I suspect that it is because it says here on my secret invisible computer, stream status good. The health is good. The health is good. All right, so I'm checking my Twitter, which is the thing that people tend to do. But I'm not doing that. I'm not doing that. I am checking the YouTube chat, and people are saying it's on. Then great. All right, so a couple things I want to do. I would like to first say a thank you. I'm noticing that there are all these little shiny icons in the YouTube chat going by for people who have joined as a member of the Coding Train. And I just want to start today, and I know there's been many people who also back via the Patreon thing, and some who have for like possibly, I don't know when I started it, but it's got to be almost like 2 years now. So thank you so much. I would say that the support that I get through those mechanisms allow for a couple things. Number one, it really motivates me because I think part of my my work ethic sort of goes a little bit, is driven by fear to some extent, in the sense that I don't want to disappoint anyone. And if there are people who are contributing some small amount of funding to the work that I do, I feel an obligation to make the videos, which is sort of weird. Maybe that's not how I should start, but sometimes it's hard to find the time, and this really helps me find the time. It also has allowed me to do a whole bunch of things in terms of hiring and paying for some technical support and video editing support and community management support over the years. A lot of people also volunteer their time to help with a lot of different things, whether it's GitHub repos. There's a whole project of developing a new website for the Coding Train that seems to be entirely volunteer driven, which makes my heart sing. So thank you for all of this kinds of support. So if you feel so inclined, there's a new member right now, Giovan Montanaro. Welcome. If you have joined as a YouTube member, I'm tentatively thinking of sunsetting the Patreon at some point. I'm not sure. It's a little bit much to maintain multiple platforms. But if you have joined as a YouTube member, check the community tab, and there are some special posts there that you can find with a link to a Google form, and we have a Slack channel and that sort of thing. So I wanted to say that. I'm just opening with like the sales pitch stuff today. Can you believe it? That's very unlike me. I don't know, I'm feeling saucy. Bernays. Okay, so the other thing I wanted to mention, because I got a couple new books recently. One book was recommended to me by Lee Tussman. The other I saw on SaberCon's Twitter. One is this book, Rise of the Video Game Zinesters: How Freaks, Normals, Amateurs, Artists, Dreamers, Dropouts, Queers, Housewives, and People Like You Are Taking Back an Art Form, by Anna Anthropy. It's like semi-translucent because there's no green, but I guess yellow is somehow, this one will be quite translucent, right? This is actually green. The bottom of this book is green, and the author's name is also green. Welcome, new member, Rock Willor. Wow, I guess I should pitch this kind of stuff more often. Hey, a shout out to Bruno Ruchiga, who posts Processing Community Day in Santa Maria, Brazil. Sorry for that. It was like some sort of attempt at Portuguese pronunciation, which I probably did terribly, is this Saturday. I know there are a bunch. The Processing Day New York City is this Saturday. Processing Day Baltimore is this Saturday. Processing Day Bangalore was just this past weekend. Oh, and Processing Day Abu Dhabi is this Saturday. So if you're not aware, but I have this tab open, I want to mention there are processing community days happening worldwide for this 1 month period between January 15th and February 15th. I have now been to just one, but I'm going to go to a second one in New York this Saturday. If you go to a Processing Community Day, share with me your experience, what you learned. But I wanted to mention these two new books that I have. Oh, Processing Day Copenhagen happened. And then I believe Simon is speaking at a Processing Community Day Amsterdam. Yes, Processing Community Day Amsterdam is this Saturday. Simon Tiger, loyal Coding Train viewer. Simon Tiger has a wonderful channel that you should also check out. Will be speaking, and I wish I could be there. I so wish I could be there, but I hope that I will get to hear about it, or if it's recorded, I will get to see it. All right, but if you are interested in books, because first of all, go to your local library, support your local library. Libraries are an amazing, wonderful thing, but another way that you can support the work that I'm doing is through the Coding Train's Amazon page, and I spent about 5 minutes looking at this page and adding some stuff to it. I added these 2 books. I haven't actually read them yet. They both just recently came via Amazon, but I keep a list of, now I made a new category for games. I have some other game books, game history books, actually some really excellent ones. I love that book by Ian Bogost about the Atari, the history of the Atari. Racing the Beam, yeah. I got to add this to my Amazon. This book is really fantastic, Racing the Beam. It's a study of the early video game console, the Atari video system. It's really fascinating to read about the kind of constraints programmers had to deal with in sort of earlier days of computing when access to RAM and resources wasn't as vast. I will add that. You can also get your own, it's not, the Million Random Digits book. I still got to find that original. Yes, I know, there's some issues with the green screen. I will address that in a second. You might like this unicorn. Maybe this is terrible for the environment and I should take this off, but it's a nice balloon unicorn thing. What do you call those? Floaty, unicorn floaty. There's some books here for beginners, data visualization books that I have here. There's probably lots more stuff that I need to add. So I'm trying to soup this up because people always ask me for, that book you mentioned, or this, do you have any recommendations? I want to learn this. Books are a wonderful thing. Again, before you buy something from Amazon, I would say go support your local library. But if you do need to order something from Amazon, if you order it through here, a little bit of money will go from the storefront. I don't know why I'm all about the money today. I woke up feeling like a little Bernays, and I'm a little bit saucy. I think actually one of the things I wanted to mention is I have gotten recently more requests from people asking to sponsor videos, and I haven't really figured out how to deal with that. I think that would be a good thing for me to do in terms of growing the channel and the possibilities of things that I can do. But I also want to be careful about not plugging some sort of product that has whether it's ethical considerations or just kind of not something that would be of interest to the viewers. But one of the things that I'm toying with is I'm hesitant to read sponsor messages on the sort of edited videos, but I feel like maybe periodically during a live stream I could possibly do that. All right, so I don't want to spend too much time, but if you have thoughts or ideas or experience with that and advice for me, get in touch. I would love to hear about it. But as you know, Coding Train Live is sponsored by water. And today, we're going to do a sponsored coding challenge about turbulent flow. None of this laminar flow. This water has really been behind on paying their bills. I get I get about 37 cents for each mention of H2O. All right, so I'm going to get started coding now. What's happening today? I have 2 other things I want to mention. I wrote some things down on a piece of paper. Breaking news. Oh wait, that's the wrong one. Coding Train breaking news. Okay. I would like to try to experiment, and Mathieu, who does video editing for the Coding Train, and I have been discussing this, different experimental things we could try in terms of editing the content after the live stream. And one of the things that would allow for a lot more possibilities is to record the green screen without, right now the only thing that I do record to disk is what you're actually seeing. So if I recorded the green screen and did a screen capture separately, that would be that would open up some possibilities after the fact. The issue is I don't know how to do that with Open Broadcast Studio, because I'm recording to disk the sort of feed, the broadcast feed. Is there a way to also record, or maybe just record instead? Maybe the green screen footage. If you have any experience with that or know the solution, please let me know.
Coding Train breaking news.
Oh, this just in. Thank you to YouTube for supporting this new project I'm about to do, which is a playlist of videos called Working with Data and APIs. Like that Google search is going to come up for what I'm looking for. Coding Train. Hey, look, I already made this playlist. No. Don't get too, oh, look, there's even a web page on that. No, this is what I'm looking for. I have made content like this before, but it was very P5 focused, which is fine and good, and it also is a little bit out of date now. So this is my new plan. I guess I should try to fix this. Oh, wait. Oh, no, it's not this. It's actually what's going on with the green screen? It's all noisy today. It's maybe this light moved. Oh, this light moved. There we go. That fixed it. YPOC writes, you could run OBS with multiple instances, one encoding a screen capture of another. Oh, did you ever try the Streamlabs version of OBS? No, I have not. I am not opposed to using commercial software. I don't know what Streamlabs offers, but I will look at that. All right, but this is something I really have to get working on this. I have made a commitment to do it. I have to do it. I'm excited to do it. But if you have thoughts or ideas about topics that would be useful for me to include under the umbrella of working with data and APIs in JavaScript, and I think I'm leaning towards the kind of like data side as opposed to the visualization side. I will make examples that create visual demonstrations, but that's not really my forte. I don't know what my forte is. I love the word forte. But it certainly is not the sort of in a visual design sensibility. So if you have ideas of topics, please file them as a GitHub issue here, a REST API, that sounds great. Be specific if you can, and I will take that under consideration. So this is coming to your YouTube TVs. I guess YouTube TV is an actual thing. So your YouTube thing soon. I'm going to do next week. I have to start this next week, even though I have 3 other ideas for things that I want to do, but I have to start this next week. I am going to start this next week. All right. That was my list. Now, I'm going to start with a warm-up today. A little throwback Wednesday. That's a thing, right? Throwback Wednesday. It's not really even a throwback. It's, apparently there's this meme. You've got to, I'm going to need some help from the young people out there to teach old man Schiffman here about memes. But apparently there's this DVD bouncing logo meme. So let's go to here. Let's go to Rainbow Topics. And this came up. Thank you to Mike Boyd's video. By the way, first of all, huge thank you to Mike Boyd, who he has a channel. Actually, I hadn't seen his channel before we made this video, but now I'm kind of addicted to it. He makes videos about how to learn stuff. I haven't really, there's so much there that I want to kind of like go through and try. You can see sort of it's starting to recommend these videos to me now over here. Actually, this is not, what account am I logged in? Oh, I'm actually logged in my account. Okay, that's fine. I usually don't like to be logged into my account while I'm live streaming, but it's fine. What am I looking? I want to say thank you to Mike Boyd, because Mike Boyd made a whole video.
Lately, there's been
Okay, yes, I hear your thought. Okay. about learning to code. Well, look, there's me, and there's the P5 logo. Learning to code and made this like amazing game, and I actually have some ideas for what I might like to do to make my own version of that game or augment the version of the game he made. Oh, and welcome to new viewers from Mike Boyd. So Best F says I subscribe to you through him. So I'm not kidding. Like if you look at my new subscribers graph, it's like so it's just like as this huge spike. I gained like a few thousand subscribers the day that he posted this video. So thank you and welcome to new viewers of Mike Boyd who are now here on the Coding Train. Yes, Coding Train is a channel where a 45-year-old human being has a toy train whistle and struggles through programming. That is a good way to summarize this channel. What was I saying? But I got the idea. I toyed with this before because I think one of the things that Mike Boyd did to first practice learning programming was to recreate the bouncing DVD logo. And I love this idea. I think, by the way, there's a website like bouncingdvdlogo.com probably. Yeah. There is a website that has this. So I love the idea of doing this because I am often looking for challenges that are super beginner friendly. I think actually the most viewed videos on my channel are the snake game and the purple rain video. And again, I'm not just here for the views. I have to admit, it's very hard to turn off that chemical thing that happens in your brain when the clicks and the likes and the fake internet points come to you. But I really want to do lots of different content, some that a lot of people might like to see and some that very few people would like to see. But I think one of the things that I'm often missing are very beginner-friendly challenges. And this, to be honest, I've done this before. This is basically like my bouncing ball in P5JS video. But this might, it's got a little zing to it with the DVD video bouncing meme thing. Plus, we can wait to see if it gets to the corner. It's very exciting. We can have lots of hijinks. So I'm gonna attempt this. That's what I'm going to start with. So what other? I want this link. And I am going to do it in editor.p5js. Oh, I want to put a bounty on something. Okay, let me talk about what I want to put a bounty on. Trust me, this is not going to be, I don't know what a good prize would be or if how to manage this. So maybe you just get a lot of thank yous. I'll send you a Coding Train t-shirt. But there's a really weird bug with the P5 web editor. Let me just go to recently updated save refresh issue. I actually made a video that demonstrates this issue. Whoa. Oh no, that's where it was in the live stream. Let me go down here. So I'm going to show you, at a certain point, you're going to see what I mean. Look at this. Let's see. Hold on. Let's make sure. Let me go back a little bit. Okay. I changed the background to 220. I hit play. Look at this. There is this thing that happens sometimes with the web editor right now, and I cannot figure it out. Cannot reproduce it. I cannot reproduce it consistently. And by the way, oh, that chat message just went by. I want to reference it. Oh, I don't have it here. It's fine. You can see that the background is 220. It's drawing. That's like a background of 100. And I'm about to refresh the page in a second. So refresh the page and background went back to 100. So there's something happening where what's in the actual code editor itself doesn't get saved, or the autosave or the saving system. There's some mismatch. I think Cassie writes here. There is an inconsistency between what is in the editor, what is in the Redux store, what's on the server when a sketch is saving, and then a user changes the editor. I think it's not getting into sync properly. So I'm having a hard time consistently being able to everybody who's encountered this has a hard time consistently reproducing this. So there's a couple things that I would love to throw out into the universe. If you can figure out this bug, oh boy, that would make me so happy. But instead of that, if you could figure out a way to consistently reproduce it, like you follow these exact steps with this timing, that would be great. Because I really want to use the P5 web editor for this coding challenge, and I think I'm going to. But I'm slightly afraid of running into this error. And also, it can cause a little bit of heartache because it's one thing for me to just lose like one little change and have to like retype it in. I think some people are losing more significant code. Simon is reminding me that there's a $1 million prize to the first person that mathematically proves the Navier-Stokes problem in 3D offered by the Clay Math Institute. That's definitely like a breaking news. I don't know why.
Breaking news.
So maybe you should work on that because I'm not offering anything like that. All right. I better get coding. It's almost 11 a.m. All right, so go into the P5 web editor. Let me go here. So let me do some I love this. This is actually a YouTube video. The science behind the perfect.
Corner now because it's done it in the lower. Yep.
It did it in the bottom right, and then it moved to the top left.
So I'm gonna bet on bottom left this time.
We want to take bets?
Yeah, let's
top
go.
Right. I'm going with bottom right.
I didn't actually watch this.
All right, and we are about to test this.
All right, so this is great. So I want to get this diagram here. Wow, they're actually like solving the math to predict which corner it's going to go to. Oh, and there's JavaScript code. This is crazy. All right. Oh, I could even use the timer. Do I dare use the timer? I don't know. Do I dare use the timer? Let's just see that this can be our fastest coding challenge yet. But before I do, what I want to do is get this. And I'm going to do this before, what do I want? I think I just want like the 64 pixel one. Hello? Oh, that's really small. Let's get a bigger one. Let's go to, let's just go to the original file. Why not, right? DVD, video logo, downloads. Tend to do this in processing, but then I'm going to put this in where we go. Let's see. DVD bouncing logo. And I'm going to do add file. Just going to do this in advance. I think. Let's do this. How is that font size wise? How's this font size wise? Pretty good, right? And if I do 400 by 300, that's 4 by 3. What does that look like? That's very small. 600 by 400 is also 4 by 3. No, it's not. I guess 800 by 600 is 4 by 3. It's kind of big, though. That's good. Let's do that. And I think I can probably cheat this over a little bit. So Anurag Hazru writes in the chat, just tried the P5 bug. I think auto reload causes the bug. I think you mean auto refresh. And you're right, I think auto refresh is related to the bug. However, I have experienced that bug even with auto refresh off. High contrast. I can do the high contrast view, yes. Thank you for that. suggestion. All right, how's this, everybody? The issue here is that I'm ultimately going to make the background black. Oh, that's fine, in high contrast even. Okay, great. Okay. You should do it as a 10-minute challenge like in the old days. Okay. I'm just like, I hesitate to overlay a timer. So what if I use, okay, I guess bear with me for a second. I've got Open Broadcast Studio. I used to do this ridiculous thing where I would put the, if you really want me, all right, let's do a quick straw poll. Use a timer on screen? Yes? No. Sure, improve spam. All right, somebody, I'm gonna vote no. No, I'm not gonna influence this. No, I don't wanna vote. Just share. No, Twitter, what? URL. If you want to vote in this, I'm sure somebody can put this into the chat who has moderator privileges. Vote there. Okay, so what I'm going to do while you're all voting is pull this up. And now, is this really true? The DVD logo moves with perfectly, is this an assumption like based on how it actually behaves? Or is this an assumption they're making just for, like just for the purpose of this article? All right, I don't know, like, because I was tempted to just make a random speed. But I guess if I could pick, it's easier, I just pick one variable, absolute speed. And maybe if it's all integer math, I could actually check if it really hits a corner. But give it like a random location, like that's what I don't know. This is why I kind of want to, like the question I have for you all is, should I be doing this with, with some kind of precision? Because I don't want to draw it out yet. Straw poll site is down. Oh. Let me just vote. Oh my God, really? Seriously? Seems to not be down. Oh, look at this. Wow, this is like, oh, you can't see this. It now shows you live. Oh, I love this. This is amazing. I got to use the straw poll stuff more often. Sort of the fact that it has ads on it. I guess I can zoom into it and then you won't be able to see the ads. There is one L missing. Where's the L? In the link. Oh. Oh, I probably, no, I probably posted the wrong link. Sorry. I'm allowing people to post the link, except the chat goes by much too fast. I can't click. Ah. Okay. All right. I can't believe that there's 141 people voting right now. That's kind of amazing. So my question for you is, this is like phone a friend. And maybe we could try to get the answer here in Slack. For this DVD logo thing, are there any constraints I need to take in mind? Like, should the speed always be a certain amount? Should where it starts be constrained? Like, how does it actually work? Oh, like this is a different website. I'm actually using this, strawpoll.me. I'm using strawpoll.me, which is a different website than strawpoll.com, apparently, which is what I've used in the past. Okay, whatever. So like, how does the DVD bouncing logo really work? Thank you, Google. Okay. All right. No, I don't want notifications. The object moves according to a vector upon hitting the boundary. Interpolate subframe. Oh, blah, 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 blah. Oh, my goodness. Oh, my goodness. Always moving in a straight line, probably a 45-degree angle. Okay. So does it start, though, in a random place? Random starting point. The logo doesn't move smoothly. It moves in chunks like 10 pixels at a time, and the x and y velocity are constant. Okay, thank you, Tushar. So if the x and y velocity are constant, are they also always equal? Is it a requirement that it moves at a vector where the components are equal, where the heading is basically 45 degrees? And do they have to be both, does it always start moving down and to the right? That's my question. Random starting point I could do. And I guess I should, but this is why I almost want to do, I want to do it with integers. Like that way I can check to see if it's equal. All right, I think this is good enough. Oh, I think people want the timer. I think that much is clear. Let's see if we've got a little screenshot of Mike Boyd doing the bouncing. Okay, where's a time code where Mike Boyd does the bouncing?
The real DVD.
Yeah, okay, here we go. And what are the dimensions of this logo file? The logo is, oh, this is black. It's not going to tint. I need to change this to white. And yeah, I need to change, I'm going to have to process this. Do I have Photoshop or something on this computer? Anybody want to quickly make me a version of this where it's white? I bet you I could. Let's see who can do this faster. Starts moving down to the right. Oh, did I not enable slow mode? That's interesting. Photoshop. That's like Photoshop. Apparently, my computer thinks it has Photoshop. Oh, hello, Creative Cloud. All right, this is like, I need the chat to teach me how to use Photoshop. I don't know how to use Photoshop. I kind of know how to use Photoshop. Where did I put it? Downloads? Okay. So I wonder if I could do just like I know I could fill it in, but what if I just do like auto color adjustments, brightness, levels. Like what if I did this? Okay, hold on. What if I did just like brightness contrast? It didn't do anything. Am I just gonna have to like fill it in? Control click on the layer. Click on Control I. Oh, Command I, that would be on a Mac. Ah! Whoever told me, what did Command I do? Invert. Ah, invert, of course. It's got this little like black outlines. I don't think anyone will care, especially when the background's black. Okay. And then let me look at image size. So let's make it, I mean, I just don't want to, let's make it, let's say 300, 100. So if my canvas is going to be 800 by 600, I probably want it to be something like 64. I mean, let's make it 128. 128 by 76. Let's try, well, first let's save it. Then let's do image size 128 by 76. Let's do save as. Save as 2. Sure, whatever. Quit Photoshop. That looks like that'll work. Now I'm going back to the editor. Delete. Let me just make sure it looks like something. Oh, I feel so lazy, but I will type this out. Let me rename this. Okay, I think we're good. That's going to work. And then just to make sure this works. Great. Okay. Are there any specific colors, or can I do a random RGB color? That's the other thing about it. Include the upload of the file in the video because it's for beginners. That's actually a good point. So let me do that. That is a very good point. So let me delete the file. And let me go to downloads. I can get rid of this stuff. Let me save this one just in case I need it. Don't need these. Okay. Then there we go. Okay. All right, the timer. Oh my God, I'm never going to get to the fluid simulation thing.
But if I run it,
Okay. All right.
thank you very much.
I like this thumbs up.
Cos theta. If Miss Mill, my maths teacher, is somehow watching this, you'll be pleased to know that 15 years later, I still got my trig down. Thank you.
Okay. All right. This is the longest warm-up ever. I totally agree. Nothing. All right, here we go. Oh, I got to do the timer. Ugh. What's the easiest way in OBS for me to add a timer? The way I did it before, it's going to take me a minute, is I opened up a Chrome window. "10-minute timer." Then I shrunk this window. And then what I did is in OBS I did add display capture. Whoops. Add timer. Oh no, that's not what I want to do. Ah, that didn't work. Turn that off. Now you see what my screen looks like. That didn't work. Add window capture. Probably window capture. Window capture. Then capture. Oh, here we go. Chrome, 10-minute timer. Okay, that's good. Then just crop it. So let me do this and then crop. What do I do? Transform, crop. Oh, that shrinks it. Can I just drag the crop? Properties? No. Copy, transform, order, transform, copy, rotate, stretch, fit, scale, filters, properties. No. I used to know how to do this because I did it once before. Yeah, I should just make my own. I mean, what I should do is, forget this. I should just put a timer in my screen here. But I was trying to do it so it's appearing in OBS. This is also like flickering in this horrible way. Let's not do this. Let's do this. 10-minute timer. That's terrible. I'm not doing it that way. Make your own timer. Yes, I can make my own timer. Ugh! I guess I could make one in processing. One must exist, but that would be so much work. I made one in P5. Do we really need a timer? No, we don't really need a timer. But now, there's got to be a way to crop this. How do I crop this? This is making me crazy. Oops. Crop. You know what? I used to do this with now I'm remembering. I used to do this with different software. Control maybe. Edit, transform. Okay, someone's telling me edit, transform. Edit, transform. Oh yeah, there's the crop. There it is. Oh my God, this computer is the worst. The delete key is broken on this computer. So I can't actually delete it. Oh, here, let's do this. Don't worry, I'm going to get there. By the way, this challenge it's taking me longer to make. I'm like sweating. It's taking me longer to make a. Wow, what just happened there? Whoa, I lost everything. Oh, no wonder. The zero. Oh, jeez Louise. This is the worst. You have no idea of what's happening. But I can't type certain numbers in without without triggering other like hotkeys that I have set up. This is insane. But now I feel like I have to. Oh my God. I cannot believe this. I'm really getting like super sweaty and I'm like panicking. I'm having like a panic attack here. The only way to do this is manually with the arrow key. I should have just done. Was just going to do a timer on my phone. That would have been better. It's okay. We're just gonna. I'm going to read to you from while I'm waiting for this to use Alt key to crop. Oh, does that actually work? I'm afraid I tried that. I thought. I'll try that again once I. You can use Alt and grab edges in OBS. Okay, let's try that. I have to give up on this because, there we go. Okay, thank you. Oops. Thank you, whoever told me I can use Alt and grab edges. This is like a game of Twister here. All right, I'm sorry, everybody. You know that I have like this sort of obsessive thing and I get stuck on stuff, which is not a good quality to have while live streaming, and I really apologize. That was not a good use of your time, my time, anybody's time. Let's move on from that. Let's get started. Oh, okay. Sorry, everybody. I actually, I got so panicky there that I feel so hot. I got to take off this sweater. And we're going to get started. Don't worry, I'm going to do the fluid simulation today. I want to apologize especially to Simon, who I think is waiting patiently for that. Okay. Here we go, everyone. Oh, I gotta start the timer. Ready? And let me do it. Let me actually change the timer to like 10 minutes and 30 seconds. Don't worry, it's coming back, everybody. I know it just went black, but it's because I have all these. I've got to change my Open Broadcast Studio settings. Okay, so I'm going to hit start. I'm going to go here, and here we go. Ready? At 10 minutes, I'm starting. Okay. Oh, I can't see the chat now. Okay, there we go. Hello, it's Throwback Wednesday, or Thursday, whatever. I'm going to do an old-fashioned coding train, coding challenge, and I'm going to make the bouncing DVD logo, and I'm going to try to be done before this timer reaches 0, which has never historically ever been a good idea. But I already lost 20 seconds. I do want to say that one of the reasons why I'm making this challenge, it shouldn't count into my time, but it's going to, is that this challenge, if you're new to programming, it's my hope that you might actually be able to follow along and understand, even if you've never programmed before. And certainly, I will include links to, in the description, where you can find some video tutorials that might actually take some more time to step through some of the concepts. And in fact, basically, I'm just redoing my bouncing ball tutorial, but I'm theming it with DVD video bouncing logo for, to attract the youth. Anyway, okay, so let's talk about what I have to do. So I have a canvas The canvas is going to be a JavaScript canvas in the browser. What? Oh, it just went off. Ah, I don't want to do any editing. Why? Why loose cable? Okay. Ugh, we can't do any. We have to. Let me just give me a second here. The timer's going, and I also. So hold on. We're gonna do. This is terrible. This is terrible. But we're gonna do a little bit of post-production magic when this gets released. So what was the timer at a moment ago when I switched and the camera went off? What was the timer at? I'm gonna reset the timer to that amount. What was the timer at? Somebody in the chat will tell me. Because I also need to put the timer here, which I forgot to do. Window capture. Okay, I'm gonna have to put slow mode on also. Seriously? God. Today's just going to be one of those days, huh? I'm seeing a lot of 902. Seeing a lot of 902. So I'm going to choose to trust that. 902. And put that up here. Okay. I guess I could start again, but I liked my intro. It was good. Ah, sorry. 9:02. Ditch the timer. I really should have ditched the timer a long time ago. That's for sure. Okay. Here we go. I'm sorry, everybody. Well, let me just fix the slow mode thing because this is really making me crazy. And then let me just go to slow mode. I'm turning slow mode on, everybody, okay? All right, everyone. What? Oh my God, you gotta be kidding me. Okay, I'm gonna I can't take it. I can't look at I really shouldn't have the chat up. All right. Second time. All right, fine. I'll restart. Let's restart, everybody. But now I have at least all right, and now, okay. Cycling the cameras. Turning this to mute. I'm going to make the same Throwback Wednesday joke. Okay. Here we go. 5, 3, 2. Hello, it's Throwback Wednesday. I don't know when you're watching this. It's probably not even Wednesday, but it is Wednesday right now. I am going to do an old-fashioned coding train style coding challenge. I'm going to attempt to make the bouncing DVD video logo, and I'm going to attempt to do it in 10 minutes. I'm sure something's going to go horribly wrong. I should never use this timer. No good never comes from it, but I'm going to try. Here's the one thing I'm excited about here with this challenge. If you are a beginner, if you have never programmed before, I'm hoping that this is a coding challenge that you could follow and actually possibly create yourself. So beginners welcome. I'm going to try to talk through all the concepts. I'm going to use very few, the basic beginner concepts of programming in JavaScript using the P5 library. Go to editor.p5js.org. I'm going to pull that up in a second where I'll be typing the code. So this is the bouncing DVD logo. And I think I got plenty of time. I'm going to wait like 20 seconds just to see if it hits the corner. Come on, come on. Oh no. Okay, anyway. I should probably move on. So what do I need? Oh, and I wanted to also do a quick shout out and thank you to Mike Boyd, who learned to code from a lot of different resources, including the Coding Train, I think. Well, check out this video. He makes this really awesome game and also at some point tries to make a bouncing DVD logo, which is where this idea came from. So let me move over to the whiteboard and just talk through a couple concepts. So I'm going to create something in HTML called a canvas, and I'm going to use the P5 library, which has a nice function for doing that called create canvas. And I'm going to make my canvas 800 by 600 because this has an aspect ratio of 4 by 3. 400 times 200 is 800 by 600, and that's the aspect ratio of old-timey television tubes. Not like this fancy YouTube with your like 16 by 9 aspect ratio. Woo, it's so fancy. And then I need to draw an image of that DVD logo. And I need to place it randomly somewhere in this canvas. Its location is going to be defined by the corner. That's going to be, it's X, Y location. And then I need to determine when it hits the edge and have it bounce off that edge. And according to my research, I actually did some research into the science behind this DVD logo thing, which you can, actually there's all sorts of formula to calculate the probability of when it's going to hit the corner and all sorts of stuff like that. I'm going to include a link to that article in this video's description. It is always moving in a direction where its X speed and its Y speed are equal. So essentially at a 45, it already starts at a 45-degree angle pointing down and then ricochets off of the edges and maybe someday hits the corner. I got 7 minutes left. Let's go. All right, so the first thing that I want to do is, I already forgot. Oh, go to the video, go to the P5 editor. This is editor.p5js.org. And you can see here I've made a canvas, it's 800 by 600, and I've drawn a background of 0. That means black. So this draw function is looping over and over again, and setup is happening just once. Set up the canvas, draw that background over and over again. So what I need is I need to keep track of that X and the Y position of the DVD logo. So I need a variable. I need X to store the X position and Y to store the Y position. And by the way the canvas works is 0, 0 is in the top left here. This is X equals 0, Y equals 0, all the way up to X equals 799. So it's 800 wide, 0 through 799. Think about that. I know I'm going too fast. Check my other tutorials where I speak hopefully a little bit slower. All right, so I'm just going to set X equal to 400 and Y equal to 300. And I'm actually just going to draw a rectangle that's like 80 by 60. A rectangle at X and Y. So I want to draw a rectangle at X and Y, and I want the width of the rectangle to be 80 and the height of the rectangle to be 60. These are P5JS, the JavaScript library P5JS functions to draw things like rectangles and circles and lines. You can look them up in the reference, which I will also link to in this video's description. Okay, there we go. Look, there it is. Woohoo! Now, I need to have something that tells me its rate of change along the x-axis and rate of change along the y-axis. I should note that y points down. Y points down, x points to the right. So if this were 3, I heard somebody say, oh, in the actual thing, it moves like 10 10 units per frame. I don't know what the old, but we can think of how many pixels does it move down into the right. So let's try with 10. So I'm going to call that x speed, and I'm going to have y speed. These, by the way, up here are known as global variables, so they're variables that I can use throughout the program. I want to initialize them in setup and then use them in draw. So I'm going to say x speed equals 10, y speed equals 10. I need separate variables because when it bounces on one side, the y continues to go down, but the x reverses direction, or when it's on the top, the y changes direction, but the x stays the same. So then what I need to do, let's just make sure this runs. It runs. What I need to do is say x equals x plus x speed, y, and let's just do that. So every time draw is looping, x equals x plus, oh, goodbye, it's gone. Run that again. Look, it's moving, oh, it's gone. So x is changing every time draw loops, which is like around 30 frames per second. And then I'm going to say y equals y plus y speed. And there we go. It's moving down. You can see that it's moving down and to the right. And now for the exciting part, I mean, isn't this all exciting? I need to figure out how do I turn it around? So I need to check. There's something in programming called an if statement. When do I want to turn it around? I want it to turn around if it hits the edge. If it hits the edge, change the value of x speed, reverse its direction. So if x speed is positive, then x speed should be negative. So I could say if x equals, and this is a little bit flawed, but I'm going to do this right now, equals the width. Width is a variable, by the way, that's keeping track of the width of the canvas, which is 800. Then x speed equals x speed times -1. Multiply any number by -1. 10 becomes -10, -10 becomes 10. Oh, I only have 3 minutes left. Got to keep moving here. Okay, there we go. Look, oh boy. Let's add also a y. If y equals the height, see what happens? Oh, what's going on here? Let's let's change where it starts. I'm just going to let it start a little bit higher so you can actually see. Look, it bounced. But one thing I'm not taking into an account, its xy position is this corner. So when it equals the edge, it's actually sitting here off of the screen. So I need to know in this corner. So actually what I want to say is when x plus its width, which is 80, plus 80 equals width, then reverse its speed. Look at that. And then when y plus what? 60 equals height. Oh, whoa. Oh, but I don't want to change the x speed. I want the y speed to change when it's y. Boom, boom. This is looking good. Okay. Now I've got to do the other spots. Well, I can use something called an else if. So I can say else if x equals 0, x speed equals x speed times -1. But you know what? There's another way I could do this. I can actually say or if x equals 0. I want to do the same thing. So this weird double pipe symbol means or. So, and by the way, to test if something is equals, I have to use 2 equals. 2 equals, and I can actually use 3, and that's a whole other story. In 1 minute, I don't have time to get to it. But there's a reason why you might use double equals or triple equals, but just more than 1 equals is asking the question. So now I'm going to say or y equals 0. Let's look at this. And then I need a close bracket. And then let's see, what's going on? I'm missing something here. Oh, I've got an extra parentheses. There we go. Okay, there we go. Okay, let me give myself a little more room here. A little more room here. Okay, here we go. Let's run this. Line 32, token, missing token, unexpected. Okay, here we go. Oh no! The bug happened! Oh no. Oh no. Oh no. Oh no. Oh no. The bug happened. The web editor bug happened. I was doing so well. Undo. 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 I knew I shouldn't hit save. Undo. Undo. Timer's at 0. Oh, wait. It came back. What just happened? Wait, what just happened? It just came back. I'm so confused. I'm so confused. This is the weirdest thing ever. Oh, I thought I turned auto save off. I wanted auto refresh on. I wanted auto refresh on, actually. I meant to have that on. But whatever. Wow, magic, right? Oh, I don't want to have any edits. Maybe we should just like speed that up. But apparently the slow mode is not on, or else there are like 20 zillion people watching today. Hi, Simon. I did see your message. Yes, I am. Sometimes I write things out in a more long-winded way just to be friendlier to the beginner, although I do take your point that actually this would probably be a nicer way to write it. Jeez Louise. I don't know what to do. I really got to get to the fluid simulation. I can't believe it's already been an hour. This is going to be my warm-up. I was going to be done with this in like 15 minutes. Do I do the whole thing again? Do we just like give up and have an edit? If I do it again, I'm at risk of the same thing happening. The slow mode is on, okay. Well, I think I just have to move on. All right. Okay, we're gonna redo? Redo? Just accept the edit, okay. I'm taking that as the gospel. I'll tell you what, I'm accepting the edit if I have time at the end of today's live stream, because I want to get to the fluid stuff. If I have time at the end of today's live stream, I will come back and redo this. All right, the timer went, I'm back. There was an edit there. The timer went to 0. My code disappeared, then it reappeared. There's like magic all around us today, but I have what I have. I now have the rectangle bouncing along the on both sides, guess what? Now that I'm doing the edit, I might as well. I get to like do that again. Okay. Let's just, okay. Oh, hi. I said I wasn't going to edit anything, but I had to take a little like short break there because my code disappeared in the browser. Then the timer went to 0, but now my code is back. It was some mystical magic floated into this room, but this is where I was a moment ago. I now have 2 if statements checking to see if this rectangle hits the right side, the left side, right side or the left side, reverse the x speed, the bottom or the top, reverse the y speed. And Simon, loyal viewer, Simon pointed out that another way I could write this is just like this. Set the speed equal to negative of itself. And there we go. Now for the really exciting moment. Let's get that DVD logo. So I've already downloaded this PNG file of the DVD logo itself. And what I'm going to do is I'm going to click on this little arrow here. I am going to add a file. Then I'm going to drag the DVD logo file here. upload it. I'm going to say I am done. And we can see now the DVD logo is part of my project. So I'm going to add some new code. I'm going to have a variable called DVD. I'm going to add something called preload. Preload is a block of code, a function where it's good to write things that you want to happen. Like, I know I said setup is stuff that happens at the beginning. Preload is like the pre-setup, and something that I want to do there is like load media assets. So I'm going to say dvd.png, what did I call it? dvd_logo.png. By the way, in the meantime, I selected this auto refresh thing so that it's like, it's rerunning the code every time I make a change. And now what I can do is, instead of drawing a rectangle, by the way, this is a way I can turn off a line of code. It's really called a code comment. I'm going to say draw the DVD logo, and I can take this exact line of code, but instead of saying rectangle, I can say image, and then I can say image, oh, what did I call it? DVD at that same location. So look at that. There's the DVD logo. Now, I might have messed with its dimensions. I can actually just use its native dimensions. Ooh, but now it's not bouncing correctly. So let's actually look at what its dimensions are. I can just, in the Apple Finder, I can see it's 128. Oh, you can't say it. 128 by 76. So I can change those numbers. But the truth of the matter is, it's not such a great idea to have hard-coded numbers in your code, like 128 and 76. But the nice thing is, I can actually say dvd.width. So the image itself, the DVD image, knows its own width. And I can also say instead plus a DVD height. And now it, whoa. No? No? How come that didn't work? Huh? That's weird. Let's just make that 128. Wait, why didn't that work? So when stuff doesn't work, I like to do use the print command, and let's just say print DVD. And I can see all this stuff. Look, width 128, height 76. How come that's not working? Width, height. Oh, I think I might know what the problem is. Oh boy, I have done something bad. I have done something bad, terrible, big mistake in coding. Aha. So it's generally not such a good idea to check if something's exactly equal, because you never know. I mean, I'm saying, oh, of course, and oh my goodness. This is really, really bad. So it only worked by accident because oh, I can't believe I didn't think of this. Because that the multiple, right? If this starts at like 100 and I'm adding 10 to it every time, and this width is 800, I am going to at some point get to the fact that it's going to be equal to 800. But if this width is like 128, x plus 128 plus some multiple of 10 is never going to actually end up equaling 800. So I just want to basically just check if it goes past the width and the height. And I'm not sure. Or what I probably want to do is resize the image to be something, but this is now going to be fine. Okay, so I can move this console down. I should do this again. This is actually what programming is, by the way. And now, here we go. Bouncing DVD logo. Some things I want to do to this. Number one is I want it to start in a random position every time, so I can use the random function. So this will now, every time I run the code, it'll start, oh, look at that. Oh, it's stuck. Oh no. Oh, God. Everything. Oh, this is the worst. This is the worst. All right, there's another problem here. Oh, because it's not, now I'm not using integer math and I'm letting it random. Oh, this is what I need to do. Let me separate this out. I'm going to be very strict about this DVD logo. I'm going to say, if it goes past the width, reverse its direction and set it to that spot. Shuffle it back. And I got to do this now separately. I got to do the same thing then I'm going to set it back equal to 0. So there's this issue that can happen where it can go kind of like past the edge and then not make it all the way back on, I think. And so I'm going to do this now for the x and the y. Huh? Oh, this is greater than height. Sorry, this is much simpler. Then y is equal to height. I lost all my energy. My balloon, my bubble has burst. All the air has come out of the balloon. But we're there. We're practically there. You see what I'm coding here? So let me just explain what I have done. Is that I have now made this a little bit more complicated, but I'm saying, okay, when it gets to the edge, if you went past the edge, just slide it back on before you turn around, right? Just set it back to this location, and this is not right with minus dvd.width, right? That's where I want to set it back to. Otherwise, if it gets to the left, set it back to the left and keep going. If it gets to the bottom, and this, of course, is height, if y plus dvd.height is greater than height, then set it back to height minus dvd.height. Okay. Yes! Okay, now, we got to do something else. I've got to add a red, green, and blue value. So I'm just going to say RGB. You can declare 3 variables at once, by the way, with commas. And then I want those values to be, you're going to see why, I want those values to be some random number between, to be honest, between 0 and 255. Then I am going to say tint RGB. So tint is a function that allows me to tint the image. Look, so every time I run this, it's going to be a different color. Now I think I want to like guarantee that it is some, that it is some, the chat is going crazy with corner, corner, corner. I swear slow mode is not on. I want it to be, to have some amount of brightness. So I could do like a hue, saturation, brightness thing, but I'm just going to limit the bottom range to 10. And then every time it hits one of the edges, I'm actually going to put this in a separate function called function pick color. And I'm going to say pick color. I'm going to call that function. So this is me making up a new function and then calling that function because I want to reuse that code. So in all of these cases, and really, there's got to be a nicer way to write this. And here we go. So now, we are done. Oh, it is now bouncing. It starts at a random location. Now, here's the thing. I have done something here quite insane and like crazy. What I would like is for you to take this code, refactor it, make it better. There's so many possibilities here. So first of all, I could add a test if it hits the corner, right? How would I do that? How would I add a test if, could I use a distance value, if it equals, if it's greater than, is it ever really going to truly hit the corner or get really close to the corner? What could I make happen? I make some fireworks go off, sort of another image appear, whatever, I don't know. But I also might want to just, for the sake of argument right now, change 800, 600 to window width, window height, and that will make it, no matter what, always do the full, then I can share this link, which is this. So now I have in the P5 editor, I guess the DVD logo size maybe should be tied to the size of the window, but I think we're done. I mean, I could sit here for a while. Maybe we'll let this just go for a little bit, and if it hits the corner, I don't know. What do we do if it hits the corner? Let me refresh this. And then we can speed this up and see if there's a moment where it hits the corner. No. It did hit the corner? Oh. Oh. Okay. Oh, here's something interesting, by the way. All right, I'm going to add something to this. Let's add a little test for if it hits the corner, okay? Just give me a second here. Let's say what we want to do is test if it hits the corner. So what I'm going to do here is I'm going to say let d equals the distance between x and y and 0, 0. So I'm just going to do the top left, okay? And I'm going to say if that distance is less than 1, like 1 pixel, then I'm going to say console log hit corner. Now it's only the top left corner. So now, here's the thing. Am I really going to sit here and watch and watch and watch and watch and watch and watch to see if the message appears there? Not really. But I could speed this up. Because what I could do is I could use something called a for loop. And basically, I could say every time through draw, do 100 cycles of moving the DVD logo and checking the corner. If it hits the corner, by the way, I'm going to say break so that it breaks out of that loop. And so now we can see it's going really, really fast. I've sort of sped it up. Come on. I don't know if, let's speed it up even more. 1,000 times. Oh! Wait, oh no, because 10,000 times. Should I let it be any corner? So I can do, one thing I can do is all the distances. Two, three, four. So this is width minus DVD dot width. Oh, well, 0, 0 is the first one. Then the other one is the top right. This would be the bottom right. This would be the bottom left. What's wrong? Oh, D4. And then I'm going to say let D equal the minimum of D1, D2, whichever one's smaller. And then D equals the minimum between D and D3. And D equals the minimum between D and D4. Let's just make sure. Yeah, okay, so it hit the corner. Whoa. Hits the corner a lot. If it's and there's certain times where it won't ever hit the corner. All right, I'm not going to include this. Start from a corner. Yeah. All right, that was an interesting aside. I'm not going to bother with that. That won't make it in. Check D. Not. Oh, was I checking D1? No wonder. Oh, yeah. Whoops. Hitting the corner a lot. Hitting the corner a lot. Okay, so it is hitting the corner quite a bit. Every 10,000 frames. It also depends on where it starts. I think there are certain places that it'll start that it won't ever get there. There's probably a way we could calculate this probability. Interesting. So it really depends on where it starts, it seems to me. Right now it's hitting the corner all the time. Drawing a path. Okay, I have to stop. All right. And thank you for watching this coding challenge. I'm sorry this turned into something of a mess. I hope that you will take this and make your own variation on it, play with it, use different imagery, different way of moving, way of checking the corner. Maybe you'll make some kind of beautiful particle effect when it hits the corner, and maybe you will think of a new idea, and who cares about the corner? How about the middle? What if it crosses the perfect middle? I don't know. The world of the bouncing DVD logo is now yours to play with. I don't know, hope you learned something, had a little bit of fun. If you want to learn more about programming, I basically do this exact same thing in my Foundations of JavaScript with P5JS tutorial series, but kind of step through all these concepts quite a bit more slowly. I don't know whether that's going to be helpful or interesting to you, but you're welcome to watch it. Thanks, and see you in a future coding challenge. All right. So, I got to put this away. I would say this was a C-. Sorry that this didn't end up being a non-edited 10-minute coding challenge. Let's go and let's do some fluid simulation, everybody. It is 12 o'clock. I've got at least another hour or hour and a half in me here. So let's see if we can do this fluid thing. The funny thing is, this was supposed to be my easy thing, and the fluid simulation is really hard. And I don't even know how I'm going to do this coding challenge, but I'm going to attempt it. So, and maybe I'll just do this one again. Thank you, Mike. Mike Boyd, I blame you. I blame you. Thumbs up, thank you. Okay, let's go to Rainbow Topics, Issues. The next thing I want to look at is here. And did I get a message from? Yes. Okay. Oh. Oh, wow. This is awesome. Thank you. Okay. Somebody could do the hypercube, the four-dimensional DVD bouncing logo. That you should do. That'll be. Oh yeah. Oh my. Wait. I kind of want to do that right now. I'm not going to. So, I was getting all these tweets yesterday about like the similarities between what I do with coding and what Bob Ross did with painting. And I would say those similarities are very few and far between. Bob Ross was like the most gentle, I hopefully I'm a gentle person, but soothing, calm, tons of talent, visual talent, slow, just meditative, lessons. I feel like that was not anything Bob Ross like whatsoever. I appreciate the comparison. Bob Ross is amazing, but it's super flawed. All right. We are going to use processing for this one. I'm going to write some concepts on the whiteboard in advance here. To try to get myself a little prepared here. Do it in 4D, please. Okay, let me come over here for a second. Let's erase this. A total disastrous failure. Let's get rid of that timer. Oh my God. That should be like a 30-minute video. Let's get rid of the timer. Don't need the timer. Lock that. Lock that. Don't need the timer. Okay. Yes, I'm going to do this in processing, which is built on top of Java. So what I want to do... whoops. Is talk about 3... Okay. So, diffusion. I was going to call it projection, but I guess, you know what, I will use the terminology that Mike Ash uses. Everything today is based on somebody. Thank you, Alan Smith. I can't believe people are joining in this with this nonsense. Diffuse, advect, actually project. Just do this in the same order. Project. And advect. I'm also going to talk about boundaries and linear solve. And I'm going to make a note of something to reference, which is Gauss upside down. I made some notes as I was reading through this stuff. I can't find my notes. My pages are all out of order now. I forgot. I was trying to look up what methodology this uses. Okay. Set boundary and yeah. Okay. So important concepts. I want to make sure I talk about incompressible versus compressible. That's another thing I wanted to talk about. And then what's sort of key here is there is the vector field, and there is the quote-unquote like die. And a concept here that's crucial is the density of the dye. Okay. So that means the amount of fluid. So this projection ties to here. This applies to, so the projection applies to only the, I think the projection applies to only the I guess it applies to the velocity. Okay, all right. Okay, sorry. So this is some concepts that I want to keep in mind as I go through this. So, oh, Simon wrote this is his favorite stream. Okay, that's nice. All right, so let me just be clear about something, although I might as well just start this coding challenge. So let me get the references that I want. I want to reference Memos library. I want to reference Joe Stam's paper and Mike Ash's blog post. Then I also want to reference LilyPad. Okay. So, all right. Oh yeah, I saw Simon. I saw everyone. I saw your video about with the balloons. Okay, thank you, Simon. All right, we're gonna get started. This is gonna be a long one, and I'm not gonna rush. Hello, YouTube Live. Very, very, very nice. Okay. All right, here we go. Let me drink some water. If this goes very smoothly, there's going to be like a tremendous amount of irony here in terms of how not smoothly the DVD thing went. By the way, I forgot to mention, looks like Wednesday, 10:30 a.m. Eastern is going to be my weekly time for live streaming. Every once in a while I might get a bonus time during the week, but I'm actually going to attempt to try every single week. There might be 1 or 2 weeks where I miss from now until the end of May. No, I'd say now until the end of April. Because May stuff changes. But now for the foreseeable future, every Wednesday, 10:30 a.m. Eastern, put it in your calendar. Complain to me on Twitter at PineappleBoy27 if that schedule doesn't work for you. No, my Twitter is actually at Schiffman. Okay, here we go. Hello and welcome to a coding challenge, a calm, soothing, although somewhat turbulent coding challenge called Fluid Simulation. Now I have something to admit to you. I don't really understand how any of this stuff works. I did make this at one point, and so I'm hoping in this coding challenge to recreate exactly this, which will be a basis on which hopefully a lot of other interesting ideas will come about. This idea came into mind when I recently saw Smarter Everyday's video on laminar flow. I love laminar flow and all, but Team Turbulence for life. Mwah! All right, so there's a wonderful 3 Blue 1 Brown. Do I just reference the same other YouTube channels every single time? Yes, I do. But there's also an excellent 3 Blue 1 Brown video on turbulence, which I would also recommend. So let me give you some background here. So first of all, there is a GitHub issue thread which started by Dear Daniel XD. from 2016, Latzman-Boltzmann methods for fluid simulation. So this is one method. I posted some stuff here, then some other stuff here. Oh, this is a great reference, I forgot, which has this like really nice simulation of turbulence in JavaScript that I would also recommend checking out. But what I want to highlight here is that what I want to highlight here are these 3 links. So the seminal kind of canonical standard, or the origins of doing like fluid dynamics in computer graphics in my research comes from this article by Joss Stam, Real-Time Fluid Dynamics for Games. I believe this is a SIGGRAPH paper, 2003. Somebody fact check me on that. And it's built on top of this idea of these Navier-Stokes equations, which are these partial differential equations that describe fluid dynamics. And there's actually a $1 million challenge for proving that this can or cannot be solved in 3 dimensions. None of this is anything I'm capable of doing, or I'm going to attempt to do in this video. But this paper includes some of the formulas, includes a lot of the code, and you can see one thing that's sort of key concept here is a fluid simulation can be done by thinking about fluid as kind of particles that live in a grid. Obviously it might be like an infinitely small grid in real life, but we can make that discrete and think about the grid of pixels and what the sort of density or the velocity of each of the fluid is at every one of these spots on the grid. That's ultimately what I'm going to do. And there's some nice C code and descriptions of some of these algorithms. Did I mention this? Oh yeah. Oh, so no. So this article, I believe, serves as the basis for Memo Atkins' processing library called MSA Fluid. This is also an open frameworks library, which is a C++ engine. And you can see here the way that this ends up looking by sort of like distorting this vector field. Oh, this is awesome. Oh, I'm sure the YouTube compression is totally ruining this, but it's beautiful. Check out that library. I could start this video just by being like, let's just use the library. And I think that's probably what you should do. Stop right now and go and use this library to make something beautiful or interesting. Read the documentation. You should also check out Gabriel Weymouth's, I hope I pronounced that correctly, Lilypad project, which was actually, I believe, used in the 3 Blue 1 Brown video on turbulence, and has, Gabriel writes here at the end a bunch of things about Stam's approach and what Lilypad does, and a paper. So this is a giant rabbit hole you could go down. And I have spent some time sort of like poking around in this rabbit hole in the last week. The article that I found that I kind of enjoyed the most in terms of style was Mike Ash's article called Fluid Simulation for Dummies, which is actually a version of Joss Stam's paper, but actually turning it into 3D and how to render that 3D with paralyzing computing power is all here in his master's thesis. That's another rabbit hole you could go down. So what I would like to do is use this article, and I try to make sure that I don't repurpose somebody else's content without permission, even if it's sort of on the web in an open source way. What I want to do, I asked Mike Ash for permission on Twitter, I think it's @MikeAsh, but I'll include a link in this video's description, if I could go through this in a video. And so what I'm going to do is I'm going to go through this in the video and mostly just kind of like copy paste this code, which is written, I believe, C++ or C, something like that, some object-oriented C flavor language. And I'm going to copy paste it into processing, which is a Java-based programming environment, and kind of like adjust the code to work in the way that I know and see if I can get the result and play with the result. So I don't feel obligated to understand or explain all of the maths involved throughout all this, and I would definitely encourage you to read this, or I would probably stop and read this whole article before you continue watching this. And then this is going to be in 3 parts at a minimum. So this first part, I hope you just like get it working. I just want to copy paste the code, change the syntax around, get it rendering, and play with it. Just get it working. Number 2 is I want to kind of refactor the code. That will be in another video. I'm actually going to refactor it with a kind of modern approach. Maybe modern is the wrong word. I mean, this was done in like over 10 years ago, but I want to use like object-oriented programming, vector, like the p-vector class in processing. I think there's some ways that I can redo the code to make it a little bit more readable than this particular style that uses a lot of like esoteric variable naming. So that's number 2. And then number 3, I want to then apply this logic to my my flow field example from the Nature of Code book. So if I could take the fluid simulation, turn it into a vector field where I could just toss particles in that fly around, I think some visual opportunities will come of that. So that's 3 parts. Just get the thing working. That's what I'm about to attempt to do right now. I'm sure it will go wrong, but I will try my best. Number 2, refactor the code to make it sort of fit with how I think about coding and processing in P5GS today. And then also try to do some more stuff with it visually. And I would say one of the things is there's going to be some performance issues. I'm going to keep things low resolution, but you'll see a lot of the implementations of this use shaders or WebGL and all sorts of fancy tricks that I'm not going to get into, but if you know about that stuff and can build on top of whatever I'm doing, then fantastic. Okay, everybody with me? Great. I'm going to take a little break, pause for a second. And I'm going to. All right, so I have written out here on the whiteboard in advance some of the key concepts that I want to make sure that I don't forget about. And I always get confused about this. Incompressible versus compressible. Which one's which? Well, I think there's a way to remember. An incompressible fluid is a fluid that basically, like, if you like squeeze it, it doesn't change its Let me do that over again. I lost my train of thought there for a second. Let me look up what the density is constant. The density is constant. That's what I meant to say. All right, so I'm about to get started coding, but before I do that, I've written in advance like a bunch of the concepts that are involved in this implementation that I want to make sure that I don't forget to mention. The first one that I think is really important is this idea of an incompressible fluid. An incompressible fluid is a fluid that's density must remain constant throughout, like water. So for example, if you have water in a balloon and you squeeze that balloon, the water's got to like come out. It's not compressible, whereas air is actually compressible. Its density can change. So this apparently, from the little research that I've done, simplifies a lot of the stuff. So this fluid simulation is going to work only for this idea of an incompressible fluid. I should also mention that the goal here is not necessarily to, with scientific accuracy, simulate like true fluid mechanics, but rather to create the illusion and feeling of that through like some like remote connection to that actual scientific accuracy. But I'm sure whatever I do will be less accurate than what people have done before me based on how I know the way I make things. All right, but that's an important thing. So the first thing that we need to consider is that the fluid is going to live inside of a box. And the way the math is sort of tuned in these examples, I believe, is so that this box should really be a square. And sometimes I don't know why, like a power of 2 is always a nice thing. So maybe I'll start with like 512 by 512, or maybe 256 by 256, just to make it low resolution. So you can think of this as a grid of pixels. And there is going to be inside of this grid a velocity vector. A velocity vector that points in a given direction. So if the velocity vector in every spot in the grid is 0, it's like completely still water. If I put a velocity vector moving to the right, it's like the water that would be like laminar flow, by the way, I think, because the velocity of everything is smooth and perfect and all moving in exactly the same direction, as opposed to turbulence where everything's kind of going crazy. So that's one thing that's going to exist in here. So that is something I should say. There is this idea of the velocity field, or the vector field, and that's going to have x's and y's. In Mike Ash's blog post, it's actually all done in 3D with x, y's, and z's, and I'm going to take out that third dimension. while I'm doing it. Then, but you should add it back in and see what happens there. Now, the other thing is there's going to be this idea of dye. Oh, I wrote this over here already because I wanted to explain that. There's this idea of dye. And we're going to talk about the density of the dye, which is, in other words, this vector field, we wouldn't be able to see anything moving through, we wouldn't be able to undersee the flow through the fluid without like putting something in it. So you could imagine sprinkling a little dye in it and having it diffuse, maybe advect, diffuse, advect, project all around the fluid. So, but what I want to make clear is when we start talking about density in this code example, and this Mike Ash makes very specific, makes a very specific point about, we're talking about the density of this dye, which is like an extra thing we're adding just so we can visualize it. We're also able to visualize it just as a vector field, which I will do at some point, but the dye is what's going to give it more this like smoky like quality by visualizing the amount of dye that's sort of as it moves throughout the fluid. So this is the basic idea. So the first thing I need to do is get an array to store all of the x's and y's of the vector field and the amount of dye for every single one of these spots. And in the example, it's done with like 3 separate arrays: an array of x's, an array of y's, and an array of densities. And it kind of works like a cellular automata simulation where I need the previous state and the next state, all the velocity of the previous and the next velocity, all the density and the next density. So I'm actually going to need 2. So this is why the code gets really confusing, because I need x, y, and density. Then I need what's in the code named as x0, y0, and density 0. I forget, this might be called like S or something in the code, but I need the sort of previous of all these. So there's a whole bunch of arrays. And this is what I want to later refactor and see if I can just use p vector or an object that stores a p vector and a density value and a previous, all that stuff. All right. Back over here. I don't know how long this has been so far. Way too long. Let's go back to Mike Ash's page. And I'm going to start with this. This is what I was talking about. So this C++ structure, I'm going to take it into processing. I'm going to add setup. I'm going to add draw. I'm going to say size 250. Actually, you know what I'm going to do? I'm going to create a variable called n. This will appear in the code, which is kind of like the width and height of the square. So it will be 5. So n is going to be, in this case, what did I say, 256. And then actually in processing, if you use a variable for the dimensions that you want to put in size, you've actually got to put that in the settings function. So I can say this. So this should get me like a 256 by 256 window. And then, so I'm going to save that. And I'm going to call this like fluid sim ash and stam, fluid sim ash stam. And then I'm going to create a class. And I'm going to call this, make a new tab, I'm going to say class fluid. And in that class, I want to have all this stuff. All of these. Now the thing that's different here in processing is this star. What is that star? What does that star mean? And that's actually because it's some C-flavored language in the code in Mike Stam's. That is a pointer, meaning it's pointing to an area, a memory address of the computer where all the density values will be stored. But what I really want this to be is just an array. So I'm going to change all of these to an array, which is the same thing in Java. This is now a pointer to an array. You'll see in a second. And by the way, I'm going to take out all the z's. I should mention, so these variables, this is a diffusion amount, like which is like a variable to control how the velocity and sort of the vectors and the dye diffuses throughout the fluid. This is viscosity. Viscosity is like the thickness of the fluid, so playing with that can change the behavior as well. dt is the time step. In all of my physics simulations I've always done, I just have the time step of 1, but I think you need a smaller time step to be able to get the simulation to behave somewhat accurately, so that'll come up later. And now I have density, and I think this is previous density, velocity x, velocity y, previous velocity x, and previous velocity y. All right, so now this is creating it, so I basically want to do exactly this. So this would be in the constructor of the fluid. And I'm not making it, and basically, n I already declared somewhere else. And I think so. I don't think I need size. I'm going to say cube size. And these should all be this dot. So this is referring to the actual variables in the object itself. And I don't need z. And I don't need z. And now, this is like, calloc is like a memory allocation because you're allocating a certain amount of memory for all these fluid values. But I just want an array that has size n times n. So this is going to be this. And it's n times n times n because his is in 3 dimensions. So I know I could do like a find and replace, but this is like so crazy that I want to do this. This is like very meditative for me. Okay, and this receives dt 3 arguments when you create the fluid. You create it with a time step, a diffusion, and a viscosity. So in here I'd be saying something like fluid, and in setup I would now say fluid equals a new fluid, maybe like a time step of 0.1, and I'm just going to make a density and viscosity of 0 for right now, but those values would get filled in presumably. Okay, we're getting there. We're moving through the article. Here we go. This is describing, okay, you need to be able to destroy the thing, free all the memory. Java, garbage collection. I don't have to worry about that. It will get cleaned up for me. Add density. Okay, this makes sense. Now remember, add density is not referring to the fluid itself. It's referring to the dye that's going into the fluid. So this is basically like an add dye. I sort of feel like I want to rename that function to add dye, but I'm going to just call it add density. So we're going to take this function. I think this could be a function that's part of the object. What does it need? We don't need a reference to the object itself. We have that. We need a location and an amount. That makes sense. So we need a location and an amount. So that's like the amount of dye we're adding at this xy spot. Now, here's the thing. You'll notice something. Everywhere in the code, there's this like ix function, index equals ix. Well, this is a two-dimensional. This is two-dimensional. But you notice all the arrays I made were one-dimensional. And this is kind of a pretty typical thing to do. But I need a way of going from x, comma y to the single index that's a lookup into this grid. So I could write a function. I think it's done with like a macro or a define or whatever in this. But I'm going to write a function. I'm going to name it. I'm going to call it ix. And it gets an x and a y. And it would just return x plus y times n. So this is, it needs to return an integer. It's not void. So this basically says for any given x, y, give me the one-dimensional index. And this formula is the same thing that I use in all my image processing and pixel processing. It's a way to get a 2D location in a one-dimensional array. Okay, so now I would be saying, and we can go back to this code basically, and we can do this, but no z. And then we're basically going to say, hey, this dot, what is it called? Vx. Oh, wait, no, that's velocity. Sorry. This dot density at index add some amount. So this is really simple. This is like a really simple function. Just add some density to this spot, this amount of density to this spot. Then we can also do this add velocity, which is basically the same thing, but just with an amount x and an amount y. So I think we could probably just copy this. And we could say add velocity at xy with an amount x and an amount y. See, I would prefer to use like p vectors for all this stuff. But, and then we get the index, and we say vx plus amount x, and vy. By the way, this is going to get, porting some of this code is going to get a lot worse soon enough. Okay, now, all right. Look at this. So here, now we can take a moment. Here are the three main operations: diffuse, project, advect. Diffuse, project, advect. Let's do them one at a time. So we can read this. I mean, it's useful to read Mike Ash's description. Put a drop of soy sauce. Soy sauce gives a way of thinking about dye, and you'll notice that it doesn't stay still, but it spreads out. So this happens even if the water and the sauce are perfectly still. It's called diffusion. And so the dye obviously diffuses. That makes sense. But the velocity also diffuses. If some of it moves, it's causing everything around it to move as well. So that's a function. This is really going to be the function that does the solving of the Navier-Stokes equation, I think, kind of. So let's go and actually write. Oh, then there's this. Okay, I'm gonna come back. Oh, see, this is describing all the functions. I kind of want to do these one at a time. So let's do diffuse. Let's do diffuse. So I'm gonna put diffuse, and this is not going to be an object inside the class, and I'll explain why in a second. So the first thing that I'm going to do is I'm just going to try to port this. So anytime there is the pointer, I want this to be an array. Diff is a diffusion amount, dt, the number of iterations, n. I don't think I need n as an argument because I'm just using that as a global variable. I also kind of personally would like to just keep iterations as a global variable. I think that'll make things a little bit simpler. Where did I put that? I'm actually going to put these in the fluid tab. That's mostly where I'm working. Final iteration, int iterations, like we can just put that as 1, but let's leave that as like 10 right now. So the idea here is that this function knows how to diffuse any arbitrary array of numbers, x, based on its previous values, x0, based on a diffusion amount and a time step. But you'll notice that what it does is immediately calls another function called linear solve. So solving a linear equation is like something like this. I don't know. 2x plus y minus 3z equals 10. Right? This is a linear equation. We can have multiple linear equations. And algorithms for solving the sort of set of solutions to this equation, what are all the x and y's and z's that make this true, is known as a process of linear solution. There are different techniques, and I was reading the comments in Mike Ash's paper. There's like this Gauss-Seidel technique. Some people did his code using this. I forget which technique his code is particularly using, but it's a way of basically solving those linear equations for fluid dynamics in the space of this grid. So that's kind of all I want to say about it. But it's needed for every single, for this diffusion algorithm. And it's really just a thing that like passes all the values all around over and over and over again with lots of iterations to sort of spread out and like a cellular automata to have the velocities or densities of neighbors affect the other neighbors and so on and so forth. So I'm now going to go and just grab the linear solve code from, whoops. What did I just, I don't know what I just, here, I'm going to grab this, and you can sort of see what it's doing. So I'm going to grab this function, I'm going to bring it in here. And by the way, this is kind of how I work. Like, I kind of want to understand this more, but I feel like I need to just like port the code and play around with it, and then maybe I could do some more research about what the equations actually are and how it's working. But sometimes this like kind of messing with the code, getting your hands on the code can sometimes help you understand the math later. So I'm gonna look at this. I'm gonna take out static. I'm gonna move this bracket over here. I don't need iterations in n. Those are gonna be the same for everything. These should be arrays. And the kind of goofy thing here is I don't need m. So I need I and j for x and y, but I can take out m. And so that loses a bracket there. And then I have to look at what's going on here. So I don't need m. And I don't need m. And I don't need m. I don't need the z. And then I also don't need to add these two components. So let's see. So the idea here is that I'm looking at, and this I've done this before. I'm having like a crazy deja vu. Is my ix function incorrect? People are noting, I have to check to make sure I got that right. But what this is now doing is saying the new value of a particular cell is based on a function of itself and all of its neighbors. And you can see that here. It is equal to its old value plus some combination of its current values. So this is kind of interesting to like sort of see how this is working. And there's some parameters here like this A parameter and this C recipe parameter. And so I got to go check. And I got to come up to this with the set bounds thing and the boundaries function in a second. But let me check the this x plus y times n. This seems right to me. Yeah, I think this is right. I mean, people are worried about, this is what it should be, but who knows? I think that's right. Okay. So then I don't need these last two arguments. So now we have the linear solve function and the diffuse function. Do I have any errors? The value of the parameter b is not used. That's strange. That's interesting. Why is it not used? Am I missing it somewhere in here? Interestingly enough. All right, well, I'm going to, because it's for set bound. Right. It has to do with set boundaries. Okay. So that's going to come up, but I'm not going to worry about that right now. Okay. I'm going to come back to that. All right, so now we're going back to the paper, and we're going to look at the next function, project. Okay, so this project function is really tied to the idea of this incompressible fluid. Because if we move all the stuff around, we have to make sure, like, something could go wrong here. Like, we could have made it so that the densities of everything are not the amount of fluid in each box. So Mike Ash has explained this much better than I have. The amount of fluid in each box has to stay constant. So the amount of fluid going in has to be exactly equal to the amount of fluid going out. So this is kind of like a cleanup stage to like put the set thing back into equilibrium. So we're going to be doing this for all the different values, all the different velocity arrays and density arrays. So let's take a look and add that project code. So let me get the project function. Well, you can see here we do project for, this is actually what the algorithm is going to be. It's diffusing for x, y, and z. Well, not for z we won't do. It's diffusing for velocity x and velocity y. It's projecting for the velocity. Advection we'll talk about. Then it's doing diffusion and advection for the density. So let me go here. And what am I trying to do? I should just follow the order of the article, but it's fine. I'm doing it my own way. I want to look for diffuse. Here it is. Oh, no, I already did that. Project. Oh, it's right here. So let's grab this. Oh, look at this craziness. So let's grab the project function. We're going to put this one in here. Okay, now we're going to port this. So these become arrays. I don't need, those are constants throughout. I like to put my bracket over here. I don't need static. Oh boy, what did I just do? That's so weird. Oh, let me paste this again. I did something really weird there. Oh, I didn't actually paste in project. Okay, sorry about that. Paste in project. These are arrays. I don't need the z. These are also arrays. And I don't need the iterations and n, those are constants. And then now I also don't need k. I only need I and j because I'm just doing 2 dimensions. I don't need k. I don't need these two. And then I don't have set boundaries yet. I'll add that. Linear solve is the same thing, but without this. And I think I can, when I do set bounds, I'll probably take out the n. Then I don't need k. I don't need k. I don't need k. I don't need k. I don't need z. And I don't need k. I don't need k. I guess probably porting Joe's stance, which was 2D, might have made more sense. And I plus 1j, I minus 1j, j plus 1, j minus 1. Yes, yes, this all makes sense. And then I don't need the z here. I think I lost a curly bracket, which would go here. And definitely screwed up something curly bracket wise. I think I have an extra curly bracket here. Okay, this looks right. Oh, I don't need the k's up here. So I'll take those out. And missing left curly bracket, and I have an extra curly bracket here. All right, we're good. We don't know what set bounds is, but that's okay. All right, whew. We now, don't worry, we're getting close. This has been quite a while I've been doing this, but I don't think it's been a half an hour because the camera hasn't shut off. So now, advection. The advec step is responsible for actually moving things around. To that end, it looks at each cell in turn. In that cell, it grabs the velocity, follows that velocity back in time, whoa, sees where it lands. So this has to do with this sort of funny thing that one of the ways that these fluid simulation algorithms work is to actually not just try to time step forward, but to actually make the decisions based on looking at where it has come from before. And so going back an extra step. So this is where all of this sort of like saving the stuff before is really, really crucial. So let's grab this advec function, and I could kind of scroll back up. Let's look at what was yeah. So this is also important. Every cell has a set of velocities, and these velocities make things move. This is called advection. As with diffusion, advection applies both to the dye and to the velocities itself. So what's really the difference between diffusion and advection? Well, diffusion is just this idea of spreading out. But advection is actually the motion associated with the velocities. They're obviously related and they both happen together, but those are separate things. So let's go grab the advection code. What? Seriously? Okay. Wow, so this I'm really going to want to unpack when I refactor this to understand what's going on. Well, I'm going to just grab it right now. Oh, this is crazy. I'm going to bring it in here. Oh boy. Ooh. Okay, ready everybody? Deep breath. Deep breath. I'm going to take out static, move this to here. I need, where's this? I need B. This is an array. This is the current density. This is the previous density. This is the current velocity. Oh. This is the current velocity. I don't need Z. Come on, scroll over. I do need dt. I mean, this could be a constant also. Let's make dt. No, I don't know. That's this dot dt. It's part of the fluid. So so that can be like this dot dt. I think. Oh, but it's. I should make that. All right, that I can pass in. Fine, I'll pass that in. I'll figure. So there's a lot of refactoring and thinking about how I want to do this, but let's leave dt in. So what could you? Are you kidding me? So these are index and previous index values. We don't need the z. We need a dt for x and a dt for y. We don't need the z. We need. This has to do with like, I think the s's are density in this. I'm not really sure. When we look through the code, but I'm going to take out the u. I don't need the 3, and I don't need the z. Oh my God, I don't need the k. I don't need the k. So, all right, so I don't need the k, part of the loop, and I don't need this last thing, and I don't need this z. And I need the x and the i's, the y's and the j's, and I don't need the z's and the k's. And I need the s's and the t's. Don't need the U's. Oh, this is really, and I don't need the K's. And now I don't need the K. And so what did I get rid of up here? I'm using, this is what I mean. Like I really want to refactor this and try to understand what each of these variables are doing and rename them. This isn't refactoring. This is just getting it to work. So I've got I's and J's X's and Y's, I's and J's, S's and T's, and no K's. And no, this is important. I need this, no K. Okay, and then I don't need this whole last section because I don't need the T's. Wait, no. Oh, wait a second. STU. ST. Where's U? I don't need U. U was the thing, if I go back to Mike Ash, U was the third dimension for the S and the T's. Okay. So what I'm actually getting rid of is this multiplication step. So one less multiplication step. Yeah, and this, right? Oh, wait, hold on. I have to stop. I have to think for a second. I think I don't need this at all. This is what I'm doing, yeah. This is much simpler. Oh, you silly third dimension. I don't need this at all. I'll line this up. And then I don't need this at all. Pretty sure. Oh, the camera went off. It's been a half an hour. All right, so I think I have refactored this to get rid of the third dimension. Well, there's still a U here. Oh, wait, I messed up. I can see if this is wrong. This should be parallel. I might have to go back to the original code. S0 plus this, S1 plus this, plus this. T1 and U0 is what I need. So it's really, except, what is this craziness? I1I, J1I, right? Oh, 0, 0, 0, 1, 1, 0. No, this is right. 1, 0, 0, 0, 0, 1. 1, 0, 1, 1, 1, 1. There we go. Okay, this is what I want. 0, 0, 0, 1, 1, 0, 1, 1. I'm pretty sure this is right. What's the chance of that? I'm going to definitely have to double check this. Double check this. And then one last thing here. Do I have the right? Okay, floor F. It's just floor, right? Because those are integers. There seems to be some extra flooring that's unnecessary here because these are floats, but I'm not sure. I'm going to leave it as is, right? And these would then have to be converted. I think there's some extra unnecessary steps here in how the numbers are being manipulated, but I'm going to just leave everything in, and I will, in part 2, we're going to get this to work. Just fast forward like 5 or 10 minutes towards the end. Okay. All right. I'm pretty sure this is now the advect function. People are telling me to leave the third dimension in. Okay. Here we go. Now, I think I actually have everything but this set boundary. So this set boundary is actually something like really nice and like compared to all that, much more manageable to understand. But basically, we've got this kind of unrealistic situation here. Well, it's not unrealistic, but we're containing the fluid within a box. And so we need some sort of mechanism for what we do with the edge cells and how we deal with those velocity vectors or things moving. And basically, we want to add some kind of like bouncing. And then we also need to deal with the corner cells even differently. in a different way. So we can read set bound. Whoops. It's everywhere. This is short for set bounds, and it's a way to keep your fluid from leaking out of your box. Not that it could really leak, writes Mike Ash. It's just a simulation in memory. But if there's no walls, right, it's obviously fluid's not going to leak out of your computer screen. That's what that was a joke there, and I just my mind hurt so much I couldn't even laugh. Ha ha. But the velocity it needs to become mirrored when it hits the wall. So if we look at what the set, and the reason why this is done in this really weird way is the set bounds function is written in a way that this b variable tells you which wall am I at? Am I at the right wall, the left wall, the top wall, the bottom wall? And I think that I could rewrite this with vectors in a way that it just kind of knows. And I don't need this extra variable b that's passed through. But once again, I am going to port it. So exactly as written. So I'm going to go back here. We can see this is all over the place. And I am going to keep this set bounds. X is any one of these arrays. So we need to do the same thing for all of the arrays, whether it's velocity X, velocity Y, or density, the density of the die. And once again, I can actually eliminate. This is for the third dimension, so I can completely take this out. No, yes, Siri, please. Can you explain to me how this fluid simulation algorithm works? So I'm going to take that out. Then I'm going to take out K. And you can see this is saying if b equals 2, you're dealing with the X stuff. Actually, it's the Y, because you can see it's looking at the top row and the bottom row. Sorry. So this is good. And then this is if b is 1. I think I might have messed this up. But I will double check. I need to get rid of the third dimension. I kind of think maybe I should have started with Joe Stam's code. Okay, let me get rid of this. This is my meditation. Let me do this right. The top, right, this is the left. Yeah, that makes sense. But the 1 and 2, that makes sense. Okay, I think we're good. But I have the K here, which makes no sense. Oh boy. This should be I and J. Yeah, sorry. These are I and J. There's no K. And this is, J is, ha. Yes, no. K is fine here. K is totally fine here. We're just doing I. For every single, okay, hold on. This just popped into my head. I think I understand what's going on here. And this is J, fine. This is absolutely fine, actually, right? Because what we need to do is we just need to account for all of these cells, all of these cells, all of these cells, and all of these cells. Now we got to do the corners separately. And the corners just does this kind of average. So these are the corners I care about, 0, 0, 0, n minus 1. Then I want n minus 1. These corners are not actual corners. Then I want n minus 1, n minus 1. I want, n minus 1, n minus 1. Oh, and I want this one. N minus 1, 0, and n minus 1, n minus 1. So these are now not corners I care about. And the idea is to average. So this should become 0.5 because there's not 3 neighbors, just 2. And we get rid of this last one. This last one. Oh, hold on. Yes, 1, 0. No. There are 3. It's just 1, 0, 0, 0, 0, 0. Do I include itself? And then 0 n minus 1 is 1 n minus 1, 0 n minus 2. Oh, I've lost my mind here. Which neighbors am I looking for? So if I'm at 0, 0, I assume the neighbors I want, this one, and itself. Is that right? I'd have to look up what, or is it this one, and this one? I think it's including itself. So in that case, it's 1, 0, 0, 1, and 0, 0. In this case, it's 1 n minus 1, 0 n minus 2, and then 0 n minus 1. That's the bottom. Then here it's n minus 2, 0, n minus 1, 1, and n minus 1, 0. And in this case, it is n minus 2, n minus 1, n minus 1, n minus 2, and one more. N minus 1, n minus 1. Oh my God. Ah, what did I do? I shouldn't have auto-formatted. Can I undo that auto-format? Yes. So let's see here. Plus, plus. What's wrong here? Oh, I still have a 0 there. Still have a 0 there. Still have a 0 there. This syntax is right. It's awkwardly written, but I'm going to leave it like this. Okay. I think we have set bounds now. All right. Oh. All right, fine. I don't think I need to pass in n. N is just a constant everywhere. So let's simplify that, and let's find the places where, ooh boy, I'm missing a bracket. I'm just checking the chat for a second. People are, how many? There's probably be like 10 viewers left. All right, okay. It's also really hard to do this with like a really big font, just so you know. So let's go through this. Fluid is fine. Add velocity, diffusion, linear solve. This has to come back without the n. Project, linear solve, boundaries, no n, no n. This is advect. And this is, semicolon. That's all that's missing there. This doesn't have the n. And, okay. Oh, what's wrong here? No, this is wrong still. My parentheses are wrong. Okay, d at I of j and j. S times t times d here, plus this. I need another, oh, this needs a semicolon. No, I'm adding all these things together. Plus, let's do this. Line this up here. Wait, why are there, okay, something is wrong here. Time out for a second. Give me a second, everybody. I'm looking up the code that I ported the other day, just because, yeah. I just want to get it right. I thought I was going to get it right without having to look it up, but it's clearly not the case. So I'm just going to look it up. Oh. Oh my goodness. I definitely will only want 2 for set boundaries. I'm not including itself. Okay. Yeah. I got it. I'll fix that. I'll fix that. Oh, this is I made this way crazier. Okay. Okay. So, a couple things. People in the chat are mentioning, I have no idea what's going on. I kind of don't either. Maybe this isn't a video that's worth watching. I'm not sure. I mean, at this point, this is just something that I'm invested in trying to do, and I will come back to it. But this, I think, is an example of why refactoring and sort of thinking about code and variable naming is a good thing. And there's nothing wrong with what was done before. This is probably perfectly appropriate and quite common styles from like over 10 years ago. But I think we could hopefully do better, and I can come back and refactor this. But I realized that I've totally got this wrong, and I have some code that I did the other day here. This should just be S0 times T, let me, S0 times T0 times, this is actually, would be easier for me to put this in one line, plus T1 times D0. So this is correct, plus, I think I might have this right, plus, S1, and I'm looking over here. Oh my goodness, oh my goodness, I get it. This is together. So this, there's no parentheses here. This is S0 times the combination of T0 times D0 plus the combination of T1 times D0 plus S1 T0 D0 plus T1 D1, another parentheses, one less parentheses maybe, and what's wrong here? Do I not? And this should be 0, 0, 0, 1, 1, 0, 1, 1. Those are all the spots. I just want to like paste it from what I had before. So many extra parentheses. And then I get rid of this parentheses. Oh, and I'm missing the plus. Okay. No? There we go. This is what I've been trying to do. I want to add those two things together times S0 and those two things together times S1. Okay. Then the other thing I messed up with the bounds is this totally should be 0.5. No, I'm like losing my mind here. There's two neighbors. There is, I'm looking at code that I ported the other day. And if I'm looking at that, I just want 0, 0, 0, n minus 1. So I just want to average. This is way, way simpler. I just want to average two of the neighbors, and for all of these different spots. And n minus 1. So this should be, and this would be semicolons all around with parentheses here. So let's make sure I'm averaging the correct indices. So for, I'm looking over here, 1, 0, 0, 0, I want 1, 0, and 0, 1, right? 0, 0, I want 1, 0, and 0, 1. 0, n minus 1, I want 1, n minus 1, 0, n minus 2. n minus 1, 0, I want n minus 2, 0, n minus 1, 1, n minus 1, n minus 1, n minus 2, n minus 1, n minus 1, n minus 2. This is right. So this is right now. Okay. Now let me, k cannot be resolved to a variable. I left a little k over here by accident. I left some k's here by accident. All right, no errors. No errors, no errors. This is, by the way, what I really like to avoid doing. I don't like to code forever and ever and ever without testing. So if this like actually works when I start to render it, I will be completely and totally gobsmacked. Okay, so now what I want to do, I've created this new fluid. I need a time step function. So I need a function time step. to step through every moment of time with the fluid. Going back to Mike Ash's paper, there is a step function, which is here, which I'm going to grab. Of course, I just wrote it out here, but what I want is void step. And I have all these as variables, but let's change that to this dot. Let's change all of these to, let's change space star to space. I wonder if, oh, no, bad idea, undo that. I'll just do this manually, because there's lots of space star where things are multiplied. What I would do is I would say this. Replace float space star. I know you can't see this. Replace float space star with float bracket star. No, float bracket space. There we go. And I think it's fine. I don't need the z's. And then I don't need the third one. I don't need the z. I don't need, and I don't need the n or the number of iterations. I don't need the z. No z, no third. I don't need n. And the way I wrote this, I don't need z. I don't need n or 4. This one is don't need n or 4. And I don't need z. I don't need n. What's wrong here? I don't need n and 4. So iterations is 4. Okay, so let's look at that. The process here is what? Diffuse the velocities, right? Diffuse the velocities based on the time step and viscosity, the x's and the y's. The 1 and the 2 is controlling the set bounds function. Then project, which is clean everything up to make sure it's the same amount of fluid everywhere, the velocities. Then run advection, advect on the velocities, x and y. Then clean all that up. Then diffuse the density and advect the density. The density doesn't need the project step because the density doesn't remain consistent around. It's the dye that actually is moving around and is inconsistent. So we should really be in, we've really got this whole thing programmed now. I should just started with, definitely should have started with Memo's library. So if I say background 0, and I say fluid step, let's run this. Hey, no errors. Oh, happy day. I mean, give me I'm going to be shocked if I can actually render this, but let's actually render this. So first, let's do a thing where as I drag the mouse, I'm going to add dye. So I'm going to add dye at mouse x, mouse y, some amount of dye. Okay? Oh, and I need to say fluid.add density. All right, no errors. That's good. That function's called. Now let's try to render. Let's call render d for rendering the density. So how am I going to do that? Oh, you know what I should actually really do? I'm going to change this to 64, and then I'm going to create a variable called scale and make that 4. And then I'm going to say size is n times scale, n times scale. So I'm actually going to lower it, and let's actually let's make the scale 10. So now we should have, well, if I comment this out, I should have 640 by 640 window. Okay. So now fluid render d. I'm going to go here and I'm going to add a function in the fluid class. I kind of want to take all these functions out and put them in a separate tab. I'm going to call this more fluid. So just like the fluid class is here, which has less stuff in it. And I'm going to say render d. So this should be pretty easy in that I'm just going to say int I equals 0, I is less than n, I plus. So I'm going to loop through. J, then I'm going to use j. Then x is going to be I times scale. Y is j times scale. I'm going to draw a rectangle at x, y, scale, which is really a square, scale, scale. By the way, did you know that processing now has the function square in it? I'm going to draw a square, get rid of that. That's going to work. I've never used this before. This is a momentous occasion 4 hours into this video. Then I'm going to say fill 255, 100. I just want to see, like, I'm just going to put an arbitrary fill. Great. So I can see all of those squares are there. I'm going to say no stroke. And then now what I want to do is the density is this dot density at the index I and j. And I'm going to make that the alpha. So d is d. So the alpha of that square, I mean, it could just be the brightness, but let's just make it the brightness directly. So it's black. Oh, array out of bounds exception. Okay, interesting. I forgot. So if I am adding fluid at mouse x and mouse y, I have to divide that now by scale because I scaled up the screen. So that has to be divided by scale. There we go. Okay, so you can see I'm adding the fluid. Great. All right, so that's something. Now I guess the water is completely still. Didn't I say it would diffuse anyway? Let's try adding some, let's try also adding some velocity. Now, how does Mike Ash approach this? Add density, add velocity. Oh, so I need to just also add, you know what I'm going to do? I have an idea. When I do that, I'm also going to add velocity at that spot. And add velocity expects what? Expects the x and y and the amount x and y. Okay, so the x and y, and now I'm going to do this. Let amount x equal mouse x minus p mouse x. P mouse x is the previous mouse possession, so the velocity is going to kind of be in the direction that I'm dragging. Not let, float. I'm in Java, not JavaScript. And an amount y is mouse y, p mouse x. So let's add that amount. Y. Let's see what happens here. Oh, okay. I don't mind that so much. We got an array out of bounds exception. So what went out of bounds? All right, well, one thing I can do here. Where's my index function? X equals constrain x to 0, n minus 1. Let's just put a constraint in here. I don't know whether I have a bug in my code or this is actually necessary, but let's do that. There we go. Oh my God. All right, this has to be under an hour because the camera only went off once, but this feels like it's been 2 hours. I think what I want to do is add something that always because look at this. I'm going to always fade out. I'm going to add something to fade. I'm going to add a function called fade d. I should really render the velocity where I'm going to say for int I equals 0, I is less than this dot density. Not length I plus plus density index I minus equal 1, and then density index I equals constrain density index I. Actually, no. I can just do this. Equals constrain. Here. Float D equals density index I. And then constrain D. I want to set equal D minus 1, but stay within 0 and 255. And then let me add fluid render fade D. I also want to render the velocity field. So just because if I add a lot, I mean, that's too much fade. I just want it to like lose, I just want it to like the dye to like peter out. Right now, I think the dye is kind of like infinite. I mean, it just keeps, it's additive. So, but this obviously, maybe I just want it to peter out more slowly. All right, so this is a nice little swirl effect. Interestingly enough, I have the diffusion and the viscosity at 0. Was that the order of the values in the constructor? dt, diffusion, viscosity. That's kind of weird. Like, what if I make it this? Whoa, that made it like really thick. That's crazy. So I think there's something maybe wrong in my code. That it's like just, oh yeah, this is like thick. Look at it. Yeah, look at the viscosity. It's like thick. So it stops. And I think I want to add also, I want to add more. Like, let me add like a higher amount. It's going to constrain it, but yeah, look at that. With a viscosity that's higher, I kind of like it with that viscosity of 0 though. So it's like, it kind of is much more turbulent. By the way, you could imagine if you had like separate RGB channels for what you're visualizing. Oh, it's been an hour. Okay. And then what about the diffusion rate? Ooh. Well, it just like, it goes away so fast. So let's just, I will worry about these later. I'm curious about also like time step. If I make that, yeah, oh, that's pretty interesting to like really lower the time step. It's just kind of happening much more slowly. But I could also probably add more iterations. I should make these here. Like what if I add 16 iterations? That probably makes it more accurate and maybe more slow, but I don't think I need that much of a time step like that. So, you know, you can play around with these variables to infinity. This is getting kind of nicer here. Now, here's what I want to do. I would like to, I mean, the other thing I could do is make this 128 and change the scale to 5. Can it? Yeah. So that's nicer. It can still perform. The frame rate is still fine. So what I want to do is I actually want to now, I'm going to just use Perlin noise really quickly and constantly add fluid. I mean, there's so many things I could do. Like I kind of want to add, I want to put like boundaries and things inside it, and there's so many possibilities. But I'm going to add, I'm just going to add density to the middle. This is what I should be doing. So what happens if I just continuously add density all the time in draw, and this has to be converted into an integer. This is kind of silly what I'm doing, but it's fine. So like I'm always adding, oh, and then let's also add, I mean, then I could, this is sort of interesting. Oh, I want to visualize the vector field. Should have done that. Let me actually really quickly do that so you can see that as well. So let me add a render v function. And what I'm going to do there is take this exact same render d, but instead, render v, I'm going to get vx equals, I think it's called v this, vy, was it not called vx and vy? What was it called? Vx, capital V. And then I want to say stroke 255, and then make a line between xy, x plus vx, x plus vy. So I just want to draw a line that shows the vector. Oh boy. So I don't, if it's 0, if Vx it does not equal 0 and Vy does not equal 0. Right, and yeah. Oh boy. I should probably only draw it if it's, oh, and this is y plus Vy. If they're, yeah, so these vector lines, you can see them. It really makes it run slow, but you can see the vector lines there. I think I should be, I should really do something more like if the, like check the magnitude of the vector. See, I just want to use p vector because it's really like if Vx is less than 0.1 and Vy is less than or equal to 0.1. Like I just don't want to draw like the vectors if they're really tiny. Oh, the absolute value? This is very silly what I'm doing. It's weird how when I start, shouldn't they all be 0? I shouldn't see anything. If they're both, oh, I'm only drawing it if they're small. If not, if they're not both small. There we go. This is what I was trying to do. So this is me drawing the vector field now. This would probably be a little bit more apparent if I changed this back. Yeah. So you can see that they're really, I should probably also like draw them bigger. I'm kind of going off the deep end here, but I should probably multiply, I should multiply this by scale, right, of course. To multiply that by scale. There we go. So you can kind of see that's the vector field where I move my mouse around. I don't know that that's as interesting visually as the die. So I'm going to go back to only rendering the die. And all right, so now the die is just sitting there in the middle, but I can kind of drag around. But what I want to do now is I'm going to take this, and I'm going to use Perlin noise. I'm going to say noise of some time, map noise of some time which goes between 0 and 1 to between -1 and 1, and amount y is the same, but I'm going to look at like a different part of the noise space. If you're not familiar with Perlin noise, I would encourage you to check out my Perlin noise videos. And then I'm going to say this also is going to be the same at this spot here. So I'm going to say int center x equals this. Int center y equals that. Then add some density at center x, center y. We could actually make this like a random amount of density, maybe. And then add the velocity according to Perlin noise. I am going to create a variable called t, which is kind of like the offset through the noise space. And I'm going to have t. Oh, I should be using, I changed my mind. I'm going to use p vector. And I'm going to say angle equals noise of t times 2 pi. And then I'm going to say a p vector is a new p vector from angle. We create a vector from angle, that angle, and then the time will go up, and this is v dot x, v dot y, and let's try. I don't know what it should be, but let's try like making the vector a little bit stronger right now. So let's see here. There we go. Yeah, this is what I was trying to do. Maybe it is too strong. Yeah, this is kind of the idea. I'm not seeing, I just wanted it to kind of like shoot it out randomly. Let's take out the fade. Let me try. Someone tell me I swapped Vx and Vy at line 96 and 97. Hold on. Let me go look at the chat. Render V of x and y. Oh. Okay. Thank you. So that's an important fix. I mean, visually we were getting some result anyway. I want to do is, let me go back to making it, let me do this. Let me add, maybe what I want to do, maybe what I actually want to do is swirl it around a bit more multiple times. Is that weird? I just wanted to do more stuff. Whoops. Why did it just do that? Oh. No. Come back to me. No, but I don't want to change. Oh, okay. Maybe I want to just, it's silly to add density multiple times, right? Oh, I know what I could do. Hold on, what's going on here? How can I get the behavior that I want? Could make it more viscous. No. Time out for a second. Apparently I did this. Let's look what I did. Like what kind of... I'm exhausted, by the way. It's 1:30. Definitely have to go soon. What did I do? Oh, interesting. Okay. Oh, I don't know. That's not right. All right, one thing I could try, I think you get the idea, but one thing that I could try is I could try kind of adding some density in, like all in a little grid pattern. So this might be sort of nice to do. And then I could say plus I. So this is just adding a lot more density. And let me turn that back to 0. And yeah, that's kind of, this is more like what I wanted. There we go. Okay, that was the velocity was too strong. Okay. So here we go. This is more what I was looking to try to do. I've got sort of Perlin noise controlling this angle. I'm just like dropping in dye constantly. It'd be sort of interesting to like sprinkle dye everywhere. There's so much you could do with color to drop particles in, but I think I'm done. I can't do this anymore. I'm very curious to see, like, to push the limits of scale and like too slow, right? Way too slow. I don't know if the rendering is too slow or the math is too slow, but I'll keep it at this. But this, I think, is a nice finished result. Okay, so let's recap what I've done. Yes, I could imagine just like twirling it around. I wanted to have some type of visualization of turbulent fluid. I think I mostly have it. And I have ported all the code from Mike Ash's page. I'm actually going to release this code as is. This isn't super long. I would really like to come back. And I would like to come back and try refactoring this to try to understand the pieces of it a bit more. I would like to, and then also I would like to create a particle simulation on top of this where I can drop in particles that sort of fly around based on the vector field. That is more like the reference on the GitHub thread, which is, where is that? Here. So I'm kind of imagining something like this, where I'm actually just going to draw particles moving around according to the vector field and see what that looks like. Then ultimately, I think what I want to do is try maybe moving to use one of these libraries, which has more a sophisticated solver and so this I think this project by Gabriel Weymouth I would like to take a look at. So I'll probably do some follow-up videos. I don't know if this was helpful or interesting. It was useful for me to try to do it. It took over an hour, but this is the process. I think, but if anything, this was useful to sort of see the process of trying to figure out somebody else's code written in another language and port it. We could try porting this to JavaScript and see if it performs even with just like raw 2D canvas. I'd be curious to see that. So go ahead and do that. Thank you for watching. I guess I shouldn't be disappointed because this works, but I do feel a little bit like, oh my God, seriously? This is what I just did? It looks more like smoke. That is correct. Team Turbulence, I don't know, I think laminar flow is where it's at. Team laminar, I switched, I've gone back. I'm on both teams. Everybody, team laminar flow and turbulent flow for everyone. Let's all get along. Goodbye. All right. Seems to be slowing down over time, which I can't exactly explain. Look at the chat here. Unless there's viscosity, it's not turbulent. That's a good point. Yeah, adding obstacles. Yes, Simon, I'm not going to be doing parts 2 and 3 now. It's already been 3 hours, which is really my limit. Yeah, why is it never pointing to the right? I mean, oh, well, Perlin noise actually has a tendency to stick by the mean, or by the, which is 0.5, and 0.5, I guess in this case, would be pi 180 degrees pointing this way. So let me fix that. So what I think would make more sense in mapping the angle is 2 pi times 2. So this we're going to get a lot more pointing around and get a lot more directions. So to me, this feels very turbulent. But technically, this is not turbulence because the viscosity is 0. Is that true? And what happens if I increase the viscosity? Like, here's the issue now that the velocity is just like really weak? Do I need more iterations? I have 16, that's pretty good. Like a really, really tiny viscosity? All right, like, I just don't understand why I get this behavior. Oh, I think there's probably a problem with the way that I'm doing the fade. Or not. This does create kind of interesting patterns, though. I need way lower viscosity. Aha! Oh! Okay, now we're talking. Yeah, that's more turbulent. Oh, I like this. Let me put the fade back in. This is kind of like what I had before, but it's more turbulent, right? Okay. So let me make that fade like even less. Because it really shouldn't have it in there. I just don't want it to like fill up all with white very quickly. Okay. So let me come at you. I don't know what's going to happen with this video, but let me come back. Let me try. So does this feel more like turbulence? Okay, yeah. I'm going to take out the fade. Forget that fade. And maybe just don't add so much. Okay. Yeah, let's try this for a second. Yeah, this is more turbulent. Okay. Let me do. Thank you to some comments from many people in the chat, but specifically Kay Weekman, who pointed out that I do not have turbulence if the viscosity is 0. So I now adjusted some things. So I created a viscosity of, and let me just zoom into this. I created a viscosity of pretty low viscosity, but it's a non-zero viscosity. I also sort of changed the way I'm adding the density and removed that fade. And you can see this has more, even though this has more of the quality of turbulence. And yes, I challenge you now, take this code and add, it's filling up now, add rainbow colors. So what if you keep a separate RGB channel? So the things that I did, just you see is like, that I'm going to publish the code with this is I actually have a pretty low viscosity. Ooh, why did the time step get so big? Yeah. And then I adjusted, the other thing that I also did is I adjusted the range of the angle to wrap around twice. So 2 pi times 2, because Perlin noise is going to tend to give me values around 0.5, so it was really sticking around pi. So this now is my final version. Let me fix up some stuff here. And this is my more turbulent version, Team Turbulence all the way. Turbulence. Okay. HSV. Okay. Stop. I should do another video of just doing interesting color stuff, because who wants to watch, if you're at the end of this video, hashtag Team Turbulence, okay? Hashtag Team Turbulence on Twitter. Let's blow it up. Of course, no one's going to have made it to the end of this video, but let's do this. Color mode. Oh no, this is render V. I want render D. Color mode, HSB 1. So, my range is between 0 and 255. So let's do fill, D, 255, 255, 100. I think this is not what I want to do. Ooh, or maybe it is. That's kind of interesting. Yeah, there we go. Except, there we go. Hue, saturation, brightness. That's pretty interesting. Team Turbulence all the way. This is my turbulence song. Unfortunately, the hue 0 maps to I feel like this would be better with like D actually being the alpha and then saying something like 255 minus D. Yeah, this is kind of interesting. Reynolds number. Yes, I didn't talk about Reynolds number. I have no energy left. All right, everyone. Oh, you should, Kate Weekman writes, you should calculate the Reynolds number will determine the behavior. Okay. Thank you. Okay, everyone. That was fun. I gotta do that data and APIs series. So I have to put all these like algorithms that I want to implement aside. And I gotta get cracking on that. Thank you for being here. Should I do that DVD logo challenge again? I have water, thank you. Should I be doing the DVD logo challenge again? I can come back later today or tomorrow. I don't know why I did 255 minus D. Or I could have done it as the brightness. Hue, saturation, brightness. That would be the same. It'd be faster. Without the alpha, it's faster. So I'm going to leave it like this. Okay, make scale smaller. Okay. I would love to make scale smaller, but I just don't think it's going to perform. It's too slow. The frame rate's really slow. What if I have the iterations? I just go to 4. Also, at this point, I should be doing it with pixels. Of course, I'm zooming into it, so that sort of defeats the purpose. I think I need to add more dye. This is like, I can play with this forever. What if I do this? Oh, I got so many new members. Let me thank everybody. Thank you, Alan Smith. Thank you, Rock Willer. Thank you, Alan Smith. Thank you, Rock Willer. Thank you, Giovan Montanaro. Thank you. Those are the members. Those are the new members. Did I miss anybody? Okay, make it 3D. Oh yeah, no problem, I'll make it 3D. Okay, everybody, thank you for watching. I'm gonna put this back into a more performative state. But I can put 16 iterations. Yeah, this is good. And much less dye. So I just wanna put it in something which I release. Okay, there we go. Huge thank you to Mike Ash, to Joe. Let me make sure I get all the credits correct. Also to Joss. I think I said Joe Stam. I apologize, Joss Stam, for all that. Okay. Yeah. All right. So I think I'm out of energy and time. I kind of, I just like, I kind of addicted to this. What I actually would love to do, I'm just gonna do one more thing. I like the idea of making it just more like full screen. Yeah. All right, so this, but it's still the same. All right. So, oh, you know what I need to do? This is for Mathieu. So what I need to do is make some thumbnails. But actually, it's better for Mathieu if I just do this. Like this. He has very lava lamp. So here. There, that's a bunch of thumbnails, green screen thumbnails for making thumbnails. And unnecessary K loop in set bounds. All right, hold on. Where's that function? Oh, it's in this page. No, I think this is right. Is it? Oh. Wait a sec. Is that right? Yeah. Yeah. Oh, sorry, you can't see the code anymore. Hold on a sec here. I know the camera just turned off. Yes. Mathieu, this is probably not going to be possible, but let me 0 I 0 minus 1. Yeah. Hold on, I'm just checking something. I wonder if I'm not doing the bounds correctly. Such a weird thing. 2 is for these. Otherwise, it's equal to negative. It bounces. If it's 2, it bounces. Okay, all right. So I don't know if this is going to be possible, but as we're editing this together, the part where I'm doing the set bounds, let me correct this. And also, that should make it more performant. And also, whoa, it's really going to do crazy inaccurate things if it does that over and over again. Oh, dare I say, I'm surprised it worked. All right, let me come back to this. Okay, because if it's equal to 2, why is it? That's not right. It should just be, yes, 1. This is so weird. Shouldn't I just be reversing itself? No, I know, but I have to fix this. Oh my God, it's almost 2 o'clock. I have to fix this. This is not right. Like what the boundary should be doing. The thing is, I just don't. The way this code is written makes no sense to me. But what it's doing is it's saying, look at all the things along the top for when you pass in 2. I mean, it really should be like if b equals 2, do this. Not the if statement in here, because they could stop the loop. This seems crazy. Right? No, I know I need to get rid of the outer loop. So I know I need to get rid of the outer loop. The question is this right? I know this is right because this is looking at all of the x values. And I thought it should just invert them. But why is this negative I1? Why is it, shouldn't this be just like negative of itself? Shouldn't it be this? right? Why does it take negative from the previous? Yeah, right? All right, okay. Well, I'm going to change it. I could be wrong. Yes, Simon, I'm going to stop very soon. I just want to fix this one last thing. Simon is asking if I'm going to stop soon. Do you need to go to bed? No, it's not that late. Yes, exactly. Okay. All right, this is actually happening later, but I'm inserting it in the point where I talk about set boundaries, because this code is crazy. The set boundaries thing is actually much simpler than this code is making it seem. So first of all, this outer loop is not necessary. I just want to look at basically all of the top row. This is up here is looking at for when y is 0, all of the x's, and when y is n minus 1, all of the x's. So this is looking at the top and the bottom. It should reverse the velocity if I'm passing in 2. This is like a really weird way to do it. Like I sort of feel like it would make more sense even just to say this and then only do that. But I'm going to leave it as is. And again, I hope to come back and refactor this using p-vector. I think that'll simplify this. But this should just be reversing its actual velocity, not the of its neighbor. Pretty sure. And then this is the same thing, but now I'm doing all of the x values along the left and all of the y values along the y. So this would be this, this and this and this. If b is 1, change it to 0, n minus 1, and 0. I don't know if this is right actually, but let's try. I'm going to try it this way. Okay, so this to me, this makes more sense to me that this is basically just this is like the bouncing ball code in like one of my very beginner tutorials. Like if you're on the edge and your stuff is coming that way, reverse it, but reverse it in the x direction for the right and left edges and the y direction for the top and bottom edges, and that's what this b is doing. Okay, so now I'm going to keep going with the challenge, and you'll eventually get to the end if you keep watching. Now let's run this and see what happens. Yeah. Let's see what happens when we get to the edge. That looks like it's leaking off now. So maybe it was supposed to be next to it. So what's the difference between doing it this way? Ooh, that's weird. I don't know what's right. So Guillermo Avila is saying this is not right, Dan, because you want to set the exact opposite value of the row column right next to it because you want the velocity derivative to 0 out. This function sets the boundary cells at the outer edges of the cube so they perfectly counteract their neighbors. I think this is the opposite of its neighbor. So is this right now? I know that this is, pretty sure this is right now. That is right. It is a closed box. Okay. So hold on. Reshoots. Just curious, like what? Why? Oh, when you have some velocity towards the wall in the next to outer layer, the wall gets a velocity that perfectly counters it. Okay, so this is actually, all right. N minus 1 is the last layer. This is to the left of it. Yeah, this is to the right of it. This is down. This is 1 above. Okay. So is this also? No, this is right. The corners are averaging. Ah, okay. Okay, so I need to, but is there not, let me just look at his code one more time. This is because it's 3D. Got it. This is because it's 3D. Got it. Okay. Okay. All right, strange edit point, but I'm jumping in here from the future in the middle of this video to explain something about this set bound function that I kind of botched while I was actually doing the challenge, and I'm at the end now, but I'm going to fix it. So one thing that's really important is just to see here, oh shoot, is that one thing that's really important is for me to point out what is written in the article by Mike Ash. Every velocity in the layer next to the outer layer is mirrored. So when you have some velocity going towards the wall in the spot next to the wall gets a velocity that perfectly counters it. That's keeping it a closed box. So that is the explanation for why here I'm saying, hey, if I'm at I, 0, any given x all along the top row, right? If y is 0, all the x's along the top, counteract the velocity from one row down. But only if I've sent in this b equals 2, which is that weird thing. And this one I think would be easier with p vector because I could do this all at once. But the thing that I have in here, I have this like leftover extra because in 3D there's more neighbors. So I actually can take this out, and this is going to make this now look correct. So this set boundary function is actually much simpler. It is just reversing the velocities in all the edge layers according to edge columns. Edge columns are rows according to the next to the edge column or row. And then for the corners, it actually just does an average of the two neighbors. And that keeps it this like walled box. So that's not, in the end, like it's kind of going to perform the same way. I just had this like extra loops in there. But this is like an important clarification. So now continue with the challenge wherever I left off. But this will be the code that's actually there when you look at this later, if you can make it to the end of this video. See you soon. Okay. Okay, did you have a link to the article? This is, if you Google Mike Ash fluid simulation, it will come up. Mike Ash fluid simulation. It's the first one. MikeAsh.com fluid simulation for dummies. Twitter.com/ I think it's Mike Ash on Twitter. Let me just look. Yes, this is the same Mike Ash. All this is credit to Mike Ash. Team Turbulence. Okay. All right, everyone. This is now, in theory, the correct version. I'm wondering, will it fill up with fluid, all red? I mean, at some point it will, right? And once I add enough dye, the dye never goes away. But I do have turbulence. And there we go. Team Turbulence! Okay. Smarter every day. This is for you. No laminar flow here. Team Turbulence. I don't like the red. I want the... I'm not really happy with the color. Just give me a second here. Am I fading it? No. Yeah, why is it all, oh, because red is, no matter what, it's red on both ends. So I would have to do something like, oh, I know what I can do. Right? Then as it starts to fill up, no? Shouldn't that have? That didn't do anything. Oh, okay, wait, hold on. There we go. This is me getting different colors. Yes, Adrian says, I'm afraid this live stream will never end. Let's just... All right, now it's going to end. All right. Team Turbulence, all the way. Here's your lava lamp of the past. This is like basically code from 2005, 14 years ago, that I have now ported into processing, and we have, we have it. All right, it's very pixelated. There's another thumbnail for Mathieu. Oop, and I just hit escape. Okay, goodbye everyone. Thank you for tuning in this week. I don't know. I'm not opposed to redoing that DVD. Not right now, although it would be kind of funny because I'd be so punchy. I'm not opposed to redoing the DVD logo challenge, but I think I'll see if Mathieu can edit something together. Combine the two. Right, I could combine the two loops. There's so much refactoring, and you know what? All right, this live stream is over. See you all next week, next Wednesday, same time, same place, 10:30 a.m. Eastern on the Coding Train. Okay, I'm still here. I have to hit the button to stop. Hit the button to stop. Okay, where is it? Okay, stop streaming. I'm hitting the button now. Goodbye.